Welcome to Science While You Sleep. I'm so glad you are here. Before we begin, let's take a moment to notice where you are right now. Maybe you are lying in bed, the blankets wrapped gently around you, feeling the softness beneath your head. Maybe you are sitting back in a quiet room, your eyes beginning to feel heavy after a long day. Or perhaps you are listening with your headphones on as you allow yourself to drift into a calm and thoughtful state. However you've arrived here, know that this space is for you, a place to relax, to let go of the constant rush of the world, and to allow your mind to wander freely. Take a slow, deep breath and let it go. Feel your shoulders release, your body loosening, your thoughts beginning to soften at the edges. Tonight, or whenever you are listening, we are going to embark on a long and gentle journey together. It is a journey into one of the greatest mysteries that humanity has ever faced. A mystery so close to us, so familiar that we rarely even notice it. It is the mystery of time. What is time? Is it a river flowing endlessly forward, carrying us with it whether we want to move or not? Is it a construct, something created by human minds to make sense of change? Is it a dimension as real and tangible as space itself, woven into the very fabric of the universe? Or is it something else entirely, something stranger than we could possibly imagine? This video is not here to give you one single answer. Instead, it will be a long meditation, a collection of reflections from philosophy, science, art, and human experience. Together, we'll explore how different cultures and thinkers have understood time, how modern physics describes it, how our own minds perceive it, and whether it is real at all as you listen. You don't need to hold on tightly to the ideas. Let them drift in and out like clouds passing across the sky. Some thoughts may catch your attention, some may blur into the background. That's perfectly fine. The flow of words is here not only to inform, but to soothe, to keep you company as you rest. Why is time mysterious? Because unlike space, which we can see and measure, or matter, which we can touch and feel, time is invisible. It is everywhere, yet nowhere. We measure it with clocks and calendars, yet we cannot hold a single second in our hands. You can remember the past, but you cannot touch it. You can anticipate the future, but you cannot step into it. All you ever have is this very moment, and even as I say the words "this moment," it has already slipped away. Time is both the most intimate and the most elusive part of our existence. It is the stage on which all of life unfolds, yet it refuses to reveal its true nature. That is why thinkers, scientists, and dreamers have returned to the question of time again and again. For thousands of years, the rhythm of your life. Think for a moment about your own day. You woke up this morning? You moved through your routines. The sun rose, it traveled across the sky, and now, perhaps, it has set. Or maybe you are on the other side of the world, where the morning is just beginning. Your entire experience of life is structured by time. The ticking of a clock, the change of seasons, the rhythm of sleep and wakefulness, the growth of your body, the memories that build your sense of self. Without time, there would be no change. Without change, there would be no life. And yet, time also brings with it a sense of fragility. Because we know, somewhere deep within, that every moment is fleeting. Every joy, every challenge, every breath is passing through us, never to return. This can be frightening, but it can also be liberating. It reminds us to cherish what we have now, time as a companion tonight, as you listen. I want you to think of time not as an enemy, not as something that slips away from you, or something you are constantly running against, but as a companion. Time is walking beside you. Every heartbeat, every inhale and exhale, every blink of your eyes is a gentle reminder that you are here, alive, part of the ongoing dance of the universe. In this way, time can feel almost like music. Just as music would not exist without rhythm, life would not exist without time. It is the invisible beat that carries all things forward, the structure of our journey and the hours ahead. We will move slowly through different ways of thinking about time. We'll begin with the everyday ways we measure it, then step back into the long history of philosophy. From there, we'll turn to the discoveries of physics, the vastness of cosmology, and the strange puzzles of time travel. We will wander through art and literature, explore the mysteries of the human mind, and finally ask the deepest question: is time real, or is it an illusion? Each section will be like a chapter in a book or a station along a journey. But remember, you don't have to follow every detail. The purpose is not only to learn, but to drift. If you fall asleep, that's perfectly okay. The words will be here, flowing gently, carrying your mind into deeper and deeper calm. An ancient question. Let's begin with a thought from St. Augustine, a philosopher who lived over 1,600 years ago. He once wrote, "What then is time? If no one asks me, I know. If I wish to explain it to him who asks, I do not know." Isn't that striking? Even in his time, with far fewer scientific tools than we have today, Augustine understood how slippery the idea of time really is. We think we know what it is until we try to explain it. This has not changed. Even with the theories of Einstein, even with quantum physics, even with our advanced clocks that measure time down to billions of a second, the essence of time still escapes us. The feeling of time passing now. Let's slow down together. Imagine yourself as a child. Think back to how summers felt then, how long a single afternoon could seem, stretching endlessly as you played. Now compare that to how time feels as an adult. Days, weeks, even years seem to slip by faster and faster. Why does this happen? Why does time seem to change depending on our age, our emotions, our state of mind? Is time speeding up, or is it our perception that shifts? This is one of the puzzles we will explore later. But for now, just notice the strangeness of it. Timeless moments. Have you ever had a moment that felt timeless? Maybe when you were deeply in love, or staring at a breathtaking sunset, or completely absorbed in creating something. For those moments, time seemed to vanish. You weren't thinking about the past or the future. You were simply present, fully alive. These moments remind us that time is not just something external, measured by clocks. It is also something internal, shaped by consciousness. The promise of this journey as we continue through this video. I invite you to relax into the mystery. You don't need to solve time tonight. No one has. But by exploring it, by letting the questions unfold slowly, you may find new ways of looking at your own life. You may find comfort or inspiration, or simply a sense of wonder. So let's step forward, gently, into the river of time together. Take another deep breath in. And out. You are ready. In the next part, we will begin by looking at how human beings first began to measure time, how we shaped our days and nights, how we built calendars, how we tamed the flow of existence into hours and minutes. But before that, rest in this thought. Time is both the most ordinary and the most extraordinary thing you will ever experience. And now, let us continue. Time is not only an abstract mystery. It is also something that shapes our daily lives in very practical ways. From the moment we wake up to the moment we go to sleep, we live according to schedules, routines, and patterns. We set alarms, we follow calendars, we check our watches or phones countless times throughout the day. Time is everywhere, quietly directing our choices. But this was not always the case. For most of human history, people lived with time in a much more natural way. They looked to the sky, to the cycles of the sun and moon, to the change of seasons to guide their lives. Before clocks, before calendars, before the mechanical measurement of seconds and minutes, time was experienced in rhythms, rhythms of light and darkness, of planting and harvest, of hunger and rest. Imagine yourself thousands of years ago. There is no clock on the wall, no buzzing phone in your pocket. The sun rises, and you wake with it. The shadows grow long, and you know evening is approaching. The moon waxes and wanes, and you track the passage of weeks. Time feels spacious, open, and deeply connected to the natural world. The first calendars, the earliest human communities, soon realized that keeping track of time was essential for survival. Farmers needed to know when to plant crops. Hunters needed to track the migration of animals. Communities needed to predict the coming of winter or the return of the rainy season. Out of this necessity came the first calendars. One of the earliest known calendars is thought to be over 30,000 years old, a series of carved notches in bones and stones, believed to mark lunar cycles. Imagine someone sitting by a fire, carving a small line for each day that the moon appeared in the night sky. This was the first attempt to capture time to freeze its flow in physical marks. Later, great civilizations created far more sophisticated systems. The Egyptians divided the year into 12 months of 30 days each, based on the flooding cycles of the Nile and the rising of the star Sirius. The Mayans built elaborate calendars that not only tracked the sun and moon, but also cycles of Venus and long historical periods that spanned thousands of years. In China, time was seen in repeating cycles, with the lunar calendar shaping festivals, rituals, and the rhythm of life. Each culture left behind traces of how they understood time. And in these traces, we see something beautiful: humanity's deep desire to find order within the passing of days. The invention of clocks, calendars, gave people a way to organize years, months, and days. But what about the smaller divisions of time, hours, minutes, and eventually seconds? The earliest attempts came in the form of sundials. With nothing more than a stick placed in the ground, people could watch the shadow move as the sun traveled across the sky. This gave them a sense of hours, though these hours changed in length depending on the season. In summer, when the days were long, the hours stretched. In winter, when the sun rose late and set early, the hours shrank. Later came water clocks, which measured time through the steady flow of liquid from one container to another. Then sandglasses, with grains trickling at a predictable rate. With these inventions, humanity began to tame time, to capture its rhythm more precisely. But it was in the Middle Ages that something truly revolutionary happened: the invention of mechanical clocks. Driven by gears and weights, these machines ticked steadily, marking time not by the sun or the flow of water, but by the relentless turning of wheels. The first public clocks were placed in church towers, ringing bells to call communities to prayer or to announce the passing of hours. For the first time, time itself was no longer tied only to nature. It had been mechanized, made into a rhythm of its own. How time changed human life! This change was profound. When clocks became part of daily life, people began to live differently. Instead of rising and resting only with the sun, they could structure their days into fixed segments. Work could be scheduled to start at a specific hour. Markets could open and close at precise times. Ships could coordinate their departures and arrivals. Slowly, time became less about nature's rhythms and more about human control. Think of how this shapes your life even now. You might wake up not because the sun has risen, but because your alarm clock tells you it is 7 a.m. You might eat lunch not because you are hungry, but because the clock says it is noon. You may stay awake long after dark, working or watching, because artificial light has freed you from the old rhythms of day and night. Time has become a grid, a structure upon which modern life is built. It allows us to coordinate with one another, to meet at the same place at the same time, even if we are strangers. But it also introduces pressure, deadlines, the sense that time is scarce, that there is never enough of it. The Industrial Revolution and time discipline. If the invention of clocks changed human life, the Industrial Revolution accelerated this transformation. Factories required workers to arrive on time, to work according to strict schedules, to follow shifts that divided the day into precise blocks. Railroads needed accurate timekeeping to coordinate trains across long distances. This gave rise to standardized time zones, replacing the old system where each city kept its own local solar time. Suddenly, time was not only personal, it became global. The clock on your wall was not just a private guide. It was part of an international system. A train leaving London at noon and arriving in Edinburgh at 4 p.m. had to mean the same thing for everyone along the route. Time became synchronized, universal, inescapable. And with this synchronization came a new relationship to life. People began to feel the constant ticking of the clock in their own bodies. Workdays became rigid. Schedules ruled over freedom. Time is money, Benjamin Franklin famously said, and the phrase captured the new age. Time had become a resource, something to save, to spend, to waste, or to lose. Our modern world of time, fast forward to today. Our lives are more bound to time than ever before. We carry digital clocks on our phones, watches, and computers, all synchronized to atomic precision. Global communication, online meetings, international travel, all depend on the exact measurement of seconds. And yet, despite this precision, many of us feel constantly rushed. We live in a culture that praises productivity, efficiency, and speed. We try to manage our time, to squeeze more and more into each day, to be faster, sharper, always ahead. But in doing so, we often lose touch with the simple, natural rhythms that once guided our ancestors. You may have felt this yourself. Maybe you look at the clock and wonder where the day has gone. Maybe you feel guilty for wasting time. Maybe you long for a slower pace, where hours feel open and generous rather than crowded and fleeting time. In our daily lives is both a gift and a burden. It gives us structure, but it can also trap us. It connects us across the globe, but it can also make us feel enslaved to the ticking of the clock. Pausing for a moment before we move deeper, take another slow breath. Notice how the idea of time feels in your own life. Do you feel that time controls you? Or do you feel that you are able to flow with it? As we move into the next part of this chapter, we will explore how our perception of time shapes our emotions, our decisions, and our sense of meaning. Because while clocks and calendars may divide time into neat pieces, the way we experience it is far more fluid, sometimes rushing, sometimes dragging, sometimes disappearing altogether. But for now, rest in this thought. Humanity has always searched for ways to capture time. From the marks on ancient bones to the gears of medieval clocks, to the glowing numbers on your phone screen tonight, all of it reflects the same longing. The longing to hold on to something that can never be held. When we think about time in our daily lives, it is not only the external schedules that matter, but also the way we personally experience its passing. You might notice that time does not always feel the same. Sometimes an hour feels endless, other times it vanishes before you can catch it. This fluidity of experience is what makes time so deeply personal. Think of moments of boredom. Perhaps you were sitting in a waiting room, staring at the wall with nothing to distract you. The minutes seemed to drag, stretching into eternity. You kept checking the clock, surprised that only 5 minutes had passed when you could have sworn it was half an hour. Now compare that to the feeling of being fully absorbed in something you love, reading a book, talking to a close friend, or playing music. Hours can pass in what feels like the blink of an eye. The clock may say 2 or 3 hours are gone, but inside you feel as if it was only a few minutes. This strange flexibility tells us something important. The passage of time is not just a physical reality measured by clocks. It is also a psychological reality measured by attention, emotion, and memory. When you are paying close attention to something, your brain takes in more detail and time feels slower. When you are distracted or absorbed, your mind skips over details. compressing the experience into what feels like a shorter span. As children, we often feel that time moves slowly. A single school year feels vast, and summer break seems endless. But as we grow older, time appears to speed up. The reason for this may lie in how the brain encodes memories. When everything is new, each day feels rich and detailed, full of fresh impressions. As adults, many experiences repeat, and the brain records them in fewer details. The result is that looking back, years feel shorter, as though they slipped by unnoticed. This explains why a 10-year-old feels like a year is a massive stretch of time, while a 50-year-old feels that a year passes almost too quickly to notice. Time itself is not changing, but our perception of it is. The richness of memory is what stretches or compresses the feeling of duration. There are also emotional influences. Fear, for example, can slow time down dramatically. Imagine the sudden jolt of being in a near accident or tripping and falling. In that instant, everything seems to move in slow motion. Your mind floods with details, every sound and image sharp, as if time itself had stretched. Scientists believe this happens because the brain is releasing stress hormones, heightening awareness, and creating an expanded record of the event. On the other hand, states of joy or deep concentration may shrink the perception of time, leaving you with the impression that hours passed in mere minutes. Technology has also reshaped how we feel time passing. In earlier centuries, nights were long, quiet, and dark, giving people hours of stillness. Today, artificial light and screens stretch the day artificially, keeping us busy long after the sun has set. Notifications, constant information, and endless entertainment compress our attention into short bursts. Many people find that weeks blur together, each day filled with so many small tasks that no single moment stands out. In this way, modern life accelerates our experience of time, not because the hours move faster, but because our attention is constantly divided. There is also the effect of routine. When you repeat the same tasks every day, time seems to pass more quickly because fewer distinct memories are created. This is why a week on vacation can feel much longer than a week at home working. The novelty of travel, new sights, new foods, new conversations creates more memory markers, stretching your sense of time. Daily repetition, in contrast, compresses it. The clock measures both weeks the same way. But your mind does not. Another fascinating aspect of daily time is the difference between clock time and inner time. Clock time is the objective ticking of seconds and minutes. Inner time is how long those seconds and minutes feel. For example, waiting for a message can feel painfully long, while being lost in a story can make you forget time altogether. This tension between the external world and the inner world is something we all navigate, often without realizing it. Some people try to control their inner time by practicing mindfulness or meditation. When you slow your breathing, pay attention to sensations, and anchor yourself in the present time feels fuller and more expansive. A single minute of awareness can feel longer than 10 minutes of distraction. This is why mindfulness practices often bring a sense of calm. They stretch your subjective time, giving you the feeling of having more of it. Think also about how memory interacts with time. A day may feel long while you are living it, but when you look back, it collapses into just a few impressions. Conversely, a day that seemed to fly by may leave behind a rich collection of memories, making it seem longer in hindsight. This is why time feels different when remembered than when lived. We also use language to shape our relationship with time. We say we spend time, save time, waste time, as if it were money in a bank. These metaphors influence how we live. If you believe time is scarce, you may rush, always anxious that you are losing it. If you see time as abundant, you may relax, allowing yourself to enjoy the present moment without fear. Neither view is entirely correct, but both shape experience deeply. And then there is sleep, the great eraser of daily time. Each night, we close our eyes and surrender hours to darkness. And when we awaken, time has passed without our awareness. Dreams give us fragmented impressions of those hours, but the rest is blank. In this way, sleep reminds us that much of life's time is lived beyond conscious notice. We wake, and the clock tells us hours are gone. But to us, it feels as if only a moment passed. All of these daily experiences, boredom, absorption, memory, emotion, technology. Sleep remind us that time is not only something out there, but also something inside us. It is both the external rhythm of clocks and the internal rhythm of consciousness. And while the external rhythm never changes, the internal rhythm is endlessly flexible, bending with mood, memory, and awareness. This is why two people can share the same hour, yet feel it completely differently. For one, it may be slow and heavy. For the other, it may be light and fleeting. Time is the same, but time is not the same. Time is not just something we check on a watch or a phone screen. It is the silent companion that shapes the rhythm of our daily existence. Think about how naturally we divide our day into morning, afternoon, and night. These divisions may feel obvious, but they are products of human interaction with the cycles of the Earth. The rotation of our planet gives us day and night, and the orbit of Earth around the Sun gives us the year. Yet beyond those natural cycles, most of what we call time in daily life is carefully structured by society. The calendar, the work week, school schedules, public holidays, even the ringing of alarms in the morning, these are layers we have added on top of nature's rhythm, creating an invisible framework that guides our every action. When you wake up, you rarely think about the concept of time itself. Instead, you think about when to leave for work, when lunch will be, or how many hours of sleep you manage to get. Each of these thoughts is built on the assumption that time is a measurable, reliable thing. And in most cases, it works. Time allows us to coordinate, to meet with others, to create systems that depend on punctuality. Without this shared framework, society would lose its ability to function smoothly. Imagine trying to take a train if everyone defined time differently. The train would never leave at the same now for everyone. So, in this sense, time acts like a common language, a universal agreement that helps billions of people organize their lives together. Yet despite this agreement, our perception of time in daily life is not constant. We have all felt how some hours fly by, while others crawl at an unbearable pace. Waiting in line for a few minutes can feel like an eternity, while spending an evening with loved ones can vanish in what feels like seconds. This is where psychology enters the picture. Our minds are not perfect clocks. They do not tick away in steady rhythms. Instead, they stretch and compress our sense of duration depending on what we are experiencing. This is why boredom makes time slow and excitement makes it vanish. In a way, our daily life is shaped less by objective time and more by subjective time, our personal, internal experience of it. Interestingly, these distortions of time are not random. They reveal how deeply time perception is tied to emotion, attention, and memory. For example, when we are deeply focused on a task, psychologists call it flow. During flow, hours can slip by unnoticed because the brain is so engaged that it stops tracking external time cues. On the other hand, when the brain is under stress, time seems to expand. Think about moments of danger, like narrowly avoiding an accident the seconds stretch. Details sharpen and time feels almost frozen. This is the brain's way of helping us process information quickly. So, the way we live and feel in our daily lives is constantly reshaping the flow of time within us. Technology has added another layer to this relationship. In the past, the sun and natural cycles set the pace. But with mechanical clocks and later digital devices, our lives became synchronized in ever more precise ways. Today, we live not by the sun, but by the second. Phones buzz with reminders, meetings start exactly on the dot, Global events are streamed live across time zones. This constant precision creates both efficiency and pressure. We save time through machines, but we also feel that time slips away faster than ever. It is a paradox as we measure time more precisely. Our subjective sense of not having enough of it increases. Another fascinating aspect is how culture influences daily time. In some cultures, punctuality is sacred. Arriving even 5 minutes late is considered rude. In others, time is more fluid, with schedules serving more as guidelines than strict boundaries. Both approaches reflect different values about community, relationships, and productivity. When you step back, you see that time is not simply universal. It is interpreted through the lens of human society, shaped by priorities and traditions. Even within a single day, a student, a doctor, and an artist might experience time completely differently depending on their roles and expectations. The modern world has also created new categories of time pressure. Many people feel trapped in the race against the clock. Deadlines, busy schedules, endless to-do lists. Time has become something to spend, waste, or save as though it were money. This way of thinking reflects how deeply we have internalized time as a commodity. Yet, if you pause and think, time itself cannot be saved or lost. It flows regardless of our desires. What we really manage is not time itself, but our choices within it. This realization can be liberating. Instead of struggling against the river of time, we can learn to navigate it more calmly, appreciating the moments as they come. There is also the personal dimension of time, the way we reflect on the past, anticipate the future, and live in the present. Daily life is not simply about moving through hours, but about constantly shifting between these three perspectives. When you recall yesterday, your memory reshapes time into a story. When you imagine tomorrow, you create possibilities that have not yet happened. And when you pause to breathe, you touch the present, the only place where life truly exists. Many traditions, from philosophy to meditation, remind us of the importance of this awareness. Living in the present may sound simple, but it challenges the way we normally race ahead in thought. It asks us to notice the small details, the warmth of sunlight, the sound of laughter, the taste of food. In those moments, time ceases to feel like a burden and becomes a gift. Perhaps the most profound realization is that daily life and time are inseparable. Every cup of coffee, every conversation, every step on the street happens within the framework of time. Yet time itself is invisible. It has no color, no weight, no form. What we experience is not time directly, but the changes and events that occur within it. This is why philosophers have long asked, does time really exist, or is it just a way for humans to organize change? In daily life, we rarely pause to ask this question. But when we do, it opens the door to deeper wonder. It reminds us that even the simplest daily routine is part of a larger mystery. So, when you think about your own day, the rush to work, the meals, the laughter with friends, the quiet moments before sleep, you are really thinking about your relationship with time. You are not just moving through hours. You are weaving them into meaning. Time in daily life is both the framework and the canvas. It gives structure to existence, yet it also bends and shifts according to the mind and heart. And perhaps that is what makes it so mysterious. For though we live in time every moment, we never fully grasp what it is. Time is one of those ideas that philosophers have never stopped questioning. Unlike a clockmaker or a physicist, the philosopher is not only interested in how time works, but in what it truly is. When you ask a simple question, like what is time? It sounds clear at first, yet the more you think about it, the harder it becomes to define. If you say time is simply the ticking of a clock, then what existed before clocks? If you say time is the movement of the sun and the stars, what about when you are deep inside a cave, cut off from all cycles of day and night? The philosophical mind pushes us to look beyond the obvious, to search for what lies beneath our assumptions. One of the earliest voices in this search was the ancient Greek philosopher Heraclitus. He believed that everything in the universe is in constant flux, always changing, always flowing. His famous phrase, "You cannot step into the same river twice," is a reflection on the nature of time itself. For Heraclitus, time was not a background stage where things happen. It was the very essence of change. Every moment is different from the one before, and this eternal motion is what creates reality. In this view, time is inseparable from transformation. Without change, there would be no time, and without time, there would be no change. But other philosophers disagreed. Parmenides, a contemporary of Heraclitus, argued almost the opposite. He suggested that change is an illusion, and that reality is ultimately timeless. According to him, all that exists is one unchanging whole. The moments we experience as flowing from past to present to future are just appearances, not the truth of reality. This tension between the flowing time of Heraclitus and the frozen eternity of Parmenides became one of the great puzzles of philosophy. Are we truly living in a universe of constant becoming, or is time itself just a trick of perception? Later, Plato added his own perspective. In his philosophy, the world we see is imperfect and fleeting, while the world of forms, the eternal, unchanging realities, exists beyond time. Time, he said, is the moving image of eternity. That is, time is how the eternal order is expressed in the physical world. Through time, we catch glimpses of something greater, but the truth itself lies outside of time. Plato's student Aristotle, however, took a more practical approach. He defined time as the number of movement in respect of before and after. In other words, time is our way of measuring motion. Without movement, there would be no time, but as long as there is change, time can be counted and compared. This definition may sound simple, yet it still echoes in modern discussions. Even today, many scientists think of time as inseparable from change, as centuries passed. Philosophers in different cultures explored time in unique ways. In ancient India, Hindu and Buddhist traditions often describe time as cyclical. The universe was not moving in a straight line from beginning to end, but endlessly repeating cycles of creation, destruction, and rebirth. In this worldview, time is not an arrow, but a wheel. Life, too, is part of this rhythm, as souls are reborn across countless lifetimes until reaching liberation. Compare this with the Abrahamic traditions, Judaism, Christianity, and Islam, where time is often seen as linear. There is a creation, a history unfolding, and an ultimate destiny, or end of time. Here, time has a direction, a purpose, a story that leads somewhere. These contrasting visions, cyclical versus linear, still shape how cultures around the world experience and interpret time. One of the most influential voices on time in the Christian tradition was St. Augustine. Living in the 4th and 5th centuries, he wrestled with a deceptively simple question: what is time? His answer remains famous: if no one asks me, I know. If I want to explain it to someone who asks me, I do not know. Augustine recognized how elusive time is. He suggested that the past no longer exists, the future has not yet come, and only the present truly is. Yet even the present is slippery before we can grasp it. It becomes the past. For him, time lived most vividly in the human mind. Memory stretches backward, expectation stretches forward, and attention rests in the fleeting now. Time, in this sense, is not just out there in the cosmos, it is woven into consciousness itself. Centuries later, as philosophy developed in Europe, thinkers like Immanuel Kant gave new depth to these ideas. Kant argued that time and space are not things in themselves, but forms of human intuition. We do not experience the world as it is, but always through the lens of our own minds. Time is one of the basic structures that allows us to perceive and understand reality. Without time, we could not make sense of events or causality. It is not that time is out there waiting to be measured, but that the human mind cannot function without organizing experiences temporally. This was a radical idea because it suggested that time might not belong to the universe at all, but to the way human beings perceive it. Other modern philosophers have taken different routes. Henry Bergson, in the 19th and early 20th centuries, made a distinction between clock time and what he called duration. Clock time is quantitative, measurable and external seconds, minutes, hours ticking away in uniform rhythm. Duration, on the other hand, is qualitative, the lived experience of time. Think again about how a joyful day feels short and a dull day feels endless. For Bergson, this inner flow of time is far more real than the mechanical ticks of a clock. He believed that philosophy should pay attention to this lived time, this continuous, indivisible flow of experience. All of these perspectives show that time is not a single, simple concept. It is many things at once: change, eternity, a measure of motion, a structure of the mind, a cycle, a story, a flow of lived moments. Philosophy does not give us one answer, but opens us to the richness of the question. And in daily life, whether we realize it or not, we carry traces of these philosophies with us. When you feel that time is a straight path, you are echoing the linear traditions. When you notice the repeating patterns of life, you are sensing the cyclical view. When you reflect on memory and anticipation, you are walking with Augustine. And when you get lost in the experience of the present, you are touching Bergson's duration. So perhaps the greatest contribution of philosophy is not to define time once and for all, but to remind us that time is mysterious, layered, and deeply connected to human thought. To live with time is to live with a question that never fully closes. When philosophy entered the modern age, the question of time took on new shapes. Thinkers were no longer only comparing eternity with change or cycles with lines. They began asking how time is lived by the individual, how it shapes existence itself. One of the most powerful traditions in this regard is existential philosophy, which places human experience at the center of reflection. Consider Martin Heidegger, a central figure in 20th century thought. For him, time was not a neutral backdrop against which life unfolds. It was the very structure of being human. We are, as he described, beings toward death. In other words, our awareness of mortality gives time its weight and urgency. The future is not just an abstract set of moments waiting to arrive. It is tied to the fact that our existence is finite. Because of this, every decision, every moment of choice carries meaning. Time, then, is not simply counted in hours, but lived through our possibilities, our projects, and our anticipation of the end. This perspective shifts time from being something out there to something deeply personal and existential. Other philosophers extended this line of thought. Jean-Paul Sartre, for instance, described human life as a tension between the past that defines us, the present in which we act, and the future we project ourselves toward. We are always surpassing ourselves, never fixed, always moving into what is not yet. Sartre saw time as a condition of freedom. It allows us to change, to create, to redefine who we are. But it also carries the anxiety of uncertainty, since the future is never guaranteed. Living within time means living within possibility and responsibility. Meanwhile, phenomenology, the philosophical study of experience, took a closer look at how time appears in consciousness. Edmund Husserl, the founder of phenomenology, suggested that our sense of the present is never a razor-thin point, but always stretches. When you listen to a melody, you don't just hear the single note striking now. You retain the memory of the note that just passed, and you anticipate the note to come. This overlap of retention and anticipation gives the flow of time its continuity. Without it, life would collapse into disconnected fragments. For Husserl, time consciousness is not a passive reception, but an active structuring of experience. a way in which the mind weaves together the flow of existence. This insight has profound consequences. It means that the way we live time is not identical to the way clocks measure it. The clock marks each second as equal. But in lived time, a second filled with joy is not equal to a second filled with sorrow. Lived time is elastic, colored by mood, shaped by intention, and rooted in memory. This distinction between objective and subjective time keeps reappearing in philosophy, reminding us that no matter how precise our instruments become, human beings remain creatures of experience, not machines of measurement beyond existentialism and phenomenology. There are also philosophies that question whether time exists at all. The British idealist J.M.E. McTaggart famously argued in the early 20th century that time is unreal. He distinguished between two ways of thinking about temporal order. The first he called the A-series, which describes events as past, present, and future. The second he called the B-series, which orders events as earlier or later than one another, without any reference to the present. McTaggart's bold claim was that the A-series leads to contradiction, because the same event would have to be past, present, and future, which is impossible. Without the A-series, he said, we cannot have real time. But since the B-series lacks a moving present, it cannot capture our actual experience of time flowing. Therefore, he concluded, time must be an illusion. Though controversial, McTaggart's argument continues to spark debates among philosophers and physicists alike. It pushes us to ask, is the flow of time real, or is it simply how human consciousness interprets change? If reality were frozen in a timeless block, would time still exist, or would it vanish along with the illusion of movement? Such questions are unsettling because they cut to the core of how we imagine existence. Eastern philosophies also offer perspectives that resonate with these puzzles. In Buddhism, for example, the impermanence of all things, what is called anicca, is central. Everything arises and passes away, including our own thoughts and feelings. Yet Buddhism also teaches that clinging to time, to the idea of a stable self moving through it, is a source of suffering. Meditation practices encourage us to return to the present moment, to see that the past is gone and the future unrealized. This focus echoes Augustine's view, but adds a spiritual dimension. Liberation comes not from escaping time, but from seeing its nature clearly and no longer being bound by it. Another perspective comes from the Taoist tradition, where time is often not treated as a rigid force, but as part of the natural flow of the Tao, the way, instead of resisting or controlling time. The Taoist sage aligns with its rhythms, finding harmony in change. Time is not an enemy or a master, but a partner in the dance of existence. This idea softens the anxiety that often accompanies Western views of time as a scarce resource. What all these traditions share, despite their differences, is the recognition that time cannot be fully grasped through measurement alone. It is not just something out there in the universe, but deeply entwined with human life, culture, and thought. Philosophers remind us that time is as much about meaning as it is about moments, as much about experience as it is about sequence. To ask, what is time, is not only to ask about physics, but to ask about ourselves, our mortality, our hopes, and our place in the cosmos. And perhaps that is why the question never ends. Time remains an open horizon, a mystery that philosophy keeps circling but never captures. Each perspective adds another layer, another angle, another insight. Together, they show us that time is not one thing, but many things, overlapping, intertwining, sometimes contradicting. It is both the river that carries us forward and the mirror in which we see ourselves reflected. In more recent philosophy, the question of time has become even sharper, often intersecting with developments in physics. Philosophers today frequently ask not only what is time, but also which concept of time best fits our scientific knowledge. These debates can feel abstract, yet they deeply influence how we think about reality itself. one central discussion revolves around two competing positions: presentism and eternalism. Presentism is the idea that only the present is real. The past has already vanished, the future does not yet exist, and all that truly is lies in the fleeting moment of now. This view feels natural, because in everyday life we experience the present as vivid and immediate, while the past lingers only in memory, and the future only in imagination. For presentists, time is like a moving spotlight, illuminating one instant after another. Eternalism, however, offers a radically different picture. According to this view, the past, present, and future all exist equally, like different places laid out in a landscape. What we call the present is just the point where our consciousness happens to stand. Eternalism is sometimes called the block universe. Theory: all of time, every moment from beginning to end, forms a four-dimensional structure already complete. The sense of flow, the feeling of time passing, is then not an objective feature of the world, but a feature of human perception. From this perspective, your birth, your present moment of listening, and your eventual death all exist side by side, each fixed in the tapestry of spec-made. Between these two extremes lies a third approach known as the growing block theory. It suggests that the past and present exist, but the future does not yet. Time is like a block that grows as events occur, adding new layers of reality with every passing instant. This allows philosophers to keep some sense of becoming while still giving existence to what has already happened. Each of these positions has its own difficulties. Presentism struggles to fit with the theory of relativity in physics, where different observers can disagree on what counts as now. Eternalism, while elegant, can feel cold or even unsettling, stripping away the immediacy of our lived experience. The growing block theory faces its own puzzles about how the future comes into being, yet together. These debates show us that time is not a settled matter, even at the most basic metaphysical level. Another strand of contemporary philosophy focuses on whether time actually flows. To most of us, the passage of time is undeniable. Seconds tick by, days slip past, years accumulate. But some philosophers argue that this flow is an illusion. From the eternalist perspective, for example, all moments simply exist, and nothing truly moves from future to present to past. Our consciousness experiences a sense of change, but reality itself is static. Others, however, defend the reality of flow, insisting that becoming is as fundamental as being. If change and novelty are real, then time's passage must also be real. The question becomes, is time a human projection, or is it woven into the fabric of the universe itself? This debate connects philosophy with neuroscience and psychology. Research into how the brain processes time suggests that our sense of the present is constructed through overlapping intervals of memory and anticipation. Some neuroscientists even suggest that what we feel as the flow of time is a cognitive invention, a way the brain organizes information for survival. But even if this is true, philosophers ask, does that mean flow is unreal? Or does it mean that human consciousness is one of the places where reality expresses time most vividly? The distinction is subtle but profound. Other philosophers bring ethics and meaning into the conversation. If time is real and fleeting, then every moment becomes precious, a chance to act before it is gone forever. If, on the other hand, eternalism is true and all events already exist, then perhaps nothing is ever truly lost. Your past joys, your loved ones, even your future choices exist eternally in the block universe. This could provide comfort, suggesting that existence is not fragile but permanent in a higher dimension. Or it could unsettle us, making our lives feel predetermined, as if freedom is an illusion. Philosophy does not resolve this tension, but it gives us tools to think it through. Contemporary thinkers also explore how time relates to identity. If the self is spread across past, present, and future, who are we really? Are you the same person you were 10 years ago, or only connected to that person by memory and continuity? If time is an illusion, is identity also an illusion? Some philosophers suggest that the self is a process, not a thing in narrative unfolding across time. Others argue for a more stable essence. In both cases, time is not just about the cosmos. It is about who we are. Another fascinating issue concerns whether time has a beginning or an end. Philosophy engages with cosmology here. Did time start with the Big Bang, or was there something before it? Can time end, or will it stretch into infinity? Ancient questions about eternity are reborn in dialogue with modern science. Philosophers probe the assumptions behind cosmological models, asking whether it even makes sense to speak of a before time began. These reflections remind us that time is not only a physical measure, but also a conceptual boundary, testing the limits of thought itself. Finally, in the most recent currents of philosophy, some thinkers embrace a pluralistic view. Perhaps there is not one single time, but many. There is physical time, measurable and precise, studied by physics. There is biological time, the rhythms of living bodies. There is psychological time, elastic and colored by feeling. And there is social time, structured by calendars, schedules, and traditions. Each of these is real in its own domain, and none can be reduced entirely to the others. Time, in this view, is not a single essence, but a family of phenomena, interwoven yet distinct. As we close this philosophical exploration, one lesson stands out. Time is not a puzzle that can be solved once and for all. It is a question that deepens the more we ask it. Philosophy reveals time as both universal and intimate, both objective and subjective, both cosmic and personal. It is the medium of change, the structure of consciousness, the measure of existence, and perhaps the greatest mystery we live within. And maybe that is the true gift of philosophy. Not to give us certainty, but to sharpen our wonder. To remind us that as you listen right now, as seconds slip by and thoughts unfold, you are participating in one of the deepest mysteries of all. Time is not just something to understand, it's something to dwell in, to question, and to live with, moment by moment. When we shift our perspective from the world of philosophy into the world of physics, time transforms from an abstract idea into something that can be measured, modeled, and described by precise laws. Physics treats time as both a coordinate in the grand stage of the universe and as an essential parameter without which motion, change, and cause and effect would be meaningless. Yet, even here, time is not entirely straightforward. What seems simple in daily life, seconds ticking on a clock, becomes astonishingly complex when viewed through the lens of scientific discovery. To begin, it is useful to consider how physics defines time. In its most basic sense, time is the measure of change. Ancient astronomers once used the steady cycles of the stars, the moon, and the sun to track time. Today, scientists use atomic clocks, where the oscillations of cesium atoms provide the most accurate measurement humanity has ever achieved. But beneath this precision lies a deeper question. Is time an external backdrop against which the universe unfolds, or is it something woven into the very fabric of reality itself? Classical mechanics, the framework developed by Isaac Newton, took time to be absolute. In Newton's world, time was universal, flowing at the same rate everywhere, for everyone, unaffected by motion or gravity. This absolute time served as the great silent river on which the events of the universe drifted. Motion could be calculated precisely because both space and time were considered fixed, stable references. If you dropped a stone, launched a cannonball, or watched the planets orbit the sun, the same time ticked forward for all observers. This view seems so intuitive, so aligned with human experience, that it reigned unchallenged for centuries. But as physics advanced into the 19th and 20th centuries, cracks began to appear in this simple picture. the discovery of the speed of light, and the realization that light traveled at the same velocity no matter the observer's motion presented a puzzle. How could time be absolute if different observers experience events differently depending on their motion? This puzzle was ultimately solved by Albert Einstein with his theory of special relativity in 1905, and it changed forever the way physicists think about time. Einstein showed that time is not absolute, but relative. The flow of time depends on the observer's state of motion. Imagine two twins. One stays on Earth, and the other boards a spaceship traveling near the speed of light. When the traveling twin returns, less time has passed for them than for the twin who remained on Earth. This is known as time dilation. At first glance, it feels impossible, but experiments with fast-moving particles and precise atomic clocks carried on aircraft and satellites have confirmed this strange reality again and again. Time does not tick at the same rate for every one night bends and stretches depending on speed. Yet, Einstein's revolution did not stop there. With general relativity, published in 1915, he went further. He revealed that gravity is not just a force pulling objects together, but a curvature of space and time itself. Massive bodies like stars and planets warp the fabric of spacetime, and this warping changes how time flows. In stronger gravitational fields, time runs slower compared to regions with weaker gravity. This means that if you place two identical clocks side by side and then moved one closer to a black hole, the clock near the black hole would tick more slowly than the one farther away. Time and space are not separate entities. They are intertwined into a four-dimensional continuum called spacetime, shaped by energy and mass. This realization has profound implications. It means there is no single, universal present moment shared across the cosmos. What is now for one observer may not be now for another, moving at a different speed or positioned in a different gravitational field. Time is not a single river flowing for everyone, but a vast network of streams, each shaped by motion and gravity. Our human intuition of a universal clock ticking the same for all is simply a local illusion. Physics also introduces the idea of the arrow of time, a concept that puzzles scientists and philosophers alike. In most equations of physics, whether describing the orbit of planets, the bouncing of particles, or the behavior of fields, time could run forward or backward, and the math would still work. Yet in our lived experience, time only flows one way forward. We remember the past, but not the future. Eggs crack, but do not uncrack. Entropy, the measure of disorder, increases, and this gives time its irreversible character. This connection between time and entropy lies at the heart of the second law of thermodynamics, one of the most fundamental principles of physics. The arrow of time, in a sense, emerges not from the equations themselves, but from the universe's initial conditions and the tendency toward greater disorder, even quantum mechanics. The physics of the smallest scales complicates our understanding of time. In the strange world of particles and probabilities, time behaves differently than in classical mechanics. Quantum systems can exist in superpositions, states that blur distinctions between before and after. The equations of quantum theory treat time as an external parameter. But some interpretations suggest that time itself might be emergent an illusion born out of deeper, timeless processes at the quantum level. What is striking is that each layer of physics reshapes our concept of time. Newton gave us absolute time. Einstein replaced it with relative time embedded in spacetime. Thermodynamics gave us the arrow of time tied to entropy. Quantum physics challenges the very reality of time as a fundamental parameter. With each step, we move further from the simple intuition of ticking clocks and closer to a view of time as a mysterious, dynamic, and perhaps even emergent aspect of the universe. And so, when we ask what time is in physics, we do not find a single answer. Instead, we discover a shifting, evolving concept that grows stranger the more closely we examine it. Time in physics is not just a backdrop, it's a player in the cosmic drama, interacting with matter, energy, and motion in ways that defy ordinary understanding. When we think about time in the physical world, it can be tempting to imagine it as something external to the universe, a container in which events happen. Yet, relativity forces us to let go of that picture. Time is not separate from the universe, it is woven into the very structure of reality. This has extraordinary consequences for how we imagine existence itself. Consider spacetime as a four-dimensional block, sometimes called the block universe. In this view, past, present, and future all coexist within this block. What we call the present is merely the slice of spacetime we are currently experiencing. From this perspective, time does not flow at all. Instead, all moments simply are, spread across the block like pages in a book, already written from the first page to the last. The sensation of movement through time, the feeling that we are carried forward from past to future, is then not a feature of physics itself, but of human consciousness. This raises profound questions. If all events are equally real, then in some sense, the future is already out there, waiting. Does this mean that free will is an illusion, that our choices are predetermined? Or does consciousness itself play a role in bringing the future into being, unfolding the pages of the block one by one? Physics itself does not answer these questions, but it sets the stage for a deep philosophical exploration. The physical consequences of relativity are not just abstract theories, but are observable and measurable. Every time you use a GPS device, you are relying on Einstein's insights into time. Satellites orbiting Earth experience both special relativity, because they are moving quickly compared to someone on the ground, and general relativity, because they are farther from Earth's gravitational field. These effects cause their onboard clocks to tick at slightly different rates than clocks on the ground. Without correcting for relativity, your GPS would accumulate errors of kilometers within a single day. What sounds like science fiction, time passing differently in space and on Earth is not only real, but essential to modern technology. As we dive deeper into physics, black holes provide perhaps the most dramatic laboratory for time. A black hole's gravity is so intense that it warps spacetime to an extreme degree. For an outside observer, as an object falls toward a black hole, time seems to slow down for the falling object. At the event horizon, time appears to freeze entirely. To the object itself, however, time continues. Normally, it crosses the horizon and continues its descent. This strange duality, where time is both frozen and flowing depending on perspective, reveals the profound relativity of time near extreme gravitational fields. Black holes remind us that time is not fixed, but malleable, stretching and bending under the influence of the cosmos's most powerful structures. But black holes also raise another mystery: what happens to time inside them? Beyond the event horizon, space-time is so warped that the roles of space and time can interchange. Instead of moving freely in space toward a location, everything is compelled to move toward the singularity, as if time itself is pulling objects inward. Inside a black hole, the future is not open-ended, but inevitable. All paths lead to the singularity. This unsettling thought forces us to confront how fragile our ordinary sense of time truly is. Time is also central to cosmology, the study of the universe as a whole. When scientists describe the Big Bang, they are not merely describing the beginning of space, but also the beginning of time. Asking what happened before the Big Bang may not even be meaningful, because time itself came into existence at that moment. This makes time not an eternal backdrop, but a property that emerged alongside space and matter. The expansion of the universe also complicates our relationship with time. Galaxies are receding from one another as the fabric of space stretches. Light from distant stars takes billions of years to reach us. meaning that when we look into the night sky, we are looking back into time. A star we see twinkling tonight may no longer exist, could have exploded long ago, but its light is only now arriving. The universe is thus a time machine, carrying us into the past whenever we look at the heavens. Cosmologists also wonder about the ultimate fate of time. If the universe continues to expand forever, galaxies will drift farther and farther apart. Stars will burn out, and black holes will slowly evaporate. In this far future, trillions of years from now, the universe will become a cold, dark place filled with sparse particles and radiation. In such a state, time loses much of its meaning, for change itself becomes rare. If entropy reaches its maximum, the arrow of time as we know it would effectively vanish. This is sometimes called the heat death of the universe. Time, so full of drama in our present age, may one day grow still and quiet. On the other hand, some theories suggest time may not continue indefinitely. If the universe eventually collapses back on itself in a big crunch, time could reverse, unwinding the cosmic story. Other proposals suggest cycles of expansion and contraction, where time is reborn endlessly in new universes. In these models, our sense of time as a single, linear thread may be too limited. The universe's time might be circular, recursive, or layered in ways we cannot yet fully imagine. Even more radical is the idea from some physicists that time might not be fundamental at all. Instead, time could be emergent, arising from deeper laws of physics that themselves are timeless. In certain formulations of quantum gravity, equations describing the universe do not contain time as a variable. Time appears only when viewed from a certain perspective, like a shadow of a more fundamental reality. If this is true, then our experience of time could be like the ripples on the surface of a pond reel, enough to us, but only a surface phenomenon hiding something deeper beneath. Physics, then, does not settle the mystery of time, it deepens it. The more precisely we measure it, the more carefully we model it, the stranger and less intuitive it becomes. What began as the ticking of a clock has become a story of warped space-time. Frozen moments at event horizons, the birth of time at the Big Bang, and perhaps even the possibility that time itself is not fundamental. And so, as we drift deeper into the physics of time, we are confronted not with clarity, but with awe. Time is not just the rhythm of our lives. It is the shifting stage of reality, bending under gravity, stretching across the cosmos, perhaps even dissolving into something beyond itself. The mystery only grows. As we move from cosmic scales to the subatomic realm, the nature of time becomes even more elusive. Quantum mechanics, the science of the very small, challenges our classical intuitions about reality, and with it, our understanding of time. Unlike in relativity, where time is intertwined with space in a smooth continuum, quantum theory introduces probabilistic events, superpositions, and entanglement, all of which complicate the picture of a single flowing timeline in the quantum world. Particles do not have definite positions or velocities until they are measured. Until that moment, they exist in a superposition, a blur of multiple possibilities. In this context, the classical notion of time as a steady, unbroken progression becomes ambiguous. When does an event truly occur? If a particle exists in multiple states simultaneously, what does it mean for one state to come before another? These questions hint that at the deepest level, time might not be as straightforward as we experience it. Entanglement adds another layer of mystery. When two particles become entangled, the state of one instantaneously affects the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, seems to defy the usual constraints of time and space. If one measurement happens here and the other happens light years away, in what order did the events occur? Quantum mechanics challenges the idea of a universal sequence, suggesting that at fundamental scales, The order of events might be more flexible than our macroscopic experience allows. Physicists also explore the idea that time could emerge from a deeper, timeless reality. In certain formulations of quantum gravity, for example, the fundamental equations describing the universe do not contain time at all. Instead, time appears only as an approximate concept when viewed from a certain perspective. Much like the way temperature emerges from the collective motion of countless particles. In such models, time is not a fundamental ingredient of reality. It is a property that arises from the interactions of underlying timeless elements. Our lived experience of past, present, and future would then be a consequence of patterns, correlations, and the structure of the universe at large. Despite these challenges, one feature of time remains striking: the arrow of time. While fundamental physical laws often work equally well forwards or backwards, the world we experience flows inexorably in one direction. Ice melts, eggs crack, stars age, and memories accumulate. This arrow is intimately tied to entropy, the measure of disorder in a system. At the Big Bang, the universe began in a state of extraordinarily low entropy. Since then, entropy has increased, providing a directionality to time. We cannot reverse the flow of entropy, and in this sense, the forward march of time is anchored in the deep structure of the cosmos. Yet the arrow of time raises paradoxes. If the laws of physics are mostly time-symmetric, why does the universe favor a single temporal direction? Scientists and philosophers alike grapple with this question. Some suggest that the asymmetry arises from boundary conditions, the special state of the universe at its birth. Others speculate that the arrow of time may be linked to the expansion of the universe itself, or even to the quantum processes that underlie reality. These questions remain open, highlighting how time, though familiar, is far from fully understood. Time travel, a popular theme in fiction, also enters serious scientific debate through these concepts. Relativity allows for solutions called closed time-like curves, paths in space-time that theoretically return to their own past. Black holes, cosmic strings, or hypothetical wormholes could, under certain extreme conditions, permit such loops. While engineering a time machine is beyond our reach, physics does not entirely forbid the idea, and it forces us to confront paradoxes. What happens if you meet your past self? Could causality cause preceding effect break down? These questions blur the line between physics and philosophy, showing that time is not just a measurement, but a profound conceptual puzzle, even at the everyday scale. Quantum experiments reveal time subtlety. Experiments with weak measurements suggest that particles can exhibit correlations across what we perceive as past and future, challenging the simple notion of cause and effect. The precise meaning of these results is still debated, but they hint that the universe at its most fundamental level may operate on principles that make our macroscopic experience of time appear continuous and linear, only as an emergent phenomenon. All these discoveries invite reflection. Time is at once familiar and alien, a framework for our lives, yet a cosmic enigma. From atomic clocks and GPS satellites to black holes and quantum particles, the universe repeatedly shows us that time is not a single, unchanging flow. It bends, it dilates, it stretches, and it might even emerge from something deeper we cannot yet fully grasp. It is both intimately connected to our consciousness and fundamentally independent of it, both measured with precision and experienced subjectively. Physics, in this sense, offers both answers and mysteries. It shows us the laws governing time, yet it also reveals the limits of our understanding. Each discovery, relativity, quantum mechanics, cosmology, pushes our intuition further, reminding us that what we call time is far more complex than ticking clocks or calendar pages. In studying time scientifically, we encounter the universe's most subtle, profound, and beautiful puzzles. As you listen now, perhaps drifting in the quiet of the night. Consider this. Every second you experience is simultaneously ordinary and extraordinary. You are moving through a cosmos where time can bend, freeze, and flow differently depending on perspective. You are participating in a dance of atoms, photons, and space-time itself. Time in physics is not only real, it is astonishing. When we think of time on Earth, we often imagine the ticking of clocks, the passing of days and seasons, or the aging of our bodies. Yet time in the cosmos stretches far beyond these human scales. Cosmological time invites us to consider the universe itself, from the Big Bang to the farthest reaches of space, and to contemplate how time flows across unimaginable distances and eras. The story of cosmological time begins with the Big Bang, the event that marks the birth of the universe nearly 13.8 billion years ago. This is not just the beginning of matter, energy, and space is also the beginning of time itself. Asking what came before the Big Bang is a question that may not make sense, because time as we know it began at that moment. From the first fractions of a second onward, the universe has been expanding, evolving, and changing, and with it, the flow of cosmic time has unfolded. One way to understand cosmological time is by thinking about light travel time. Light from distant galaxies takes millions or even billions of years to reach us. When we look at the night sky, we are not seeing the universe as it is now, but as it was in the past. The Andromeda Galaxy, for example, is about 2.5 million light-years away. When we observe it tonight, we see it as it was 2.5 million years ago, long before humans walked the Earth. In this way, the universe is a natural time machine, allowing us to witness cosmic history directly through observation. Another essential aspect of cosmological time is the scale of cosmic evolution. Stars live for millions to billions of years. Galaxies collide and merge over similar spans. And black holes can persist for durations far exceeding the lifespan of any star. The processes that shape the universe occur over epochs so vast that human lifetimes are barely perceptible. To think in cosmological time is to expand our sense of what a moment can mean, to consider the patience and immensity of the cosmos itself. Time in cosmology is also shaped by the universe's expansion. Edwin Hubble's observations in the 1920s revealed that galaxies are moving away from one another, and the farther a galaxy is, the faster it appears to recede. This observation gave birth to the concept of an expanding universe, and with it, a cosmological timescale. Astronomers measure cosmic time by tracing the expansion backward, estimating the age of galaxies, stars, and cosmic structures. In this sense, time is not just a backdrop, it's a dimension deeply connected to the universe's geometry and history. Cosmological time also allows us to consider the ultimate fate of the universe. Current observations suggest that the expansion of the universe is accelerating due to a mysterious force called dark energy. If this acceleration continues, the universe will grow colder, emptier, and darker. Stars will burn out, galaxies will drift apart, and black holes will slowly evaporate through Hawking radiation. Trillions of years from now, the universe could reach a state of near-perfect uniformity and maximum entropy, a scenario sometimes called the heat death. In such a distant future, the concept of time as we experience each with change in events would become nearly meaningless, for change itself would be vanishingly rare. Yet cosmological time is not only about the distant past or the far future. It also intersects with the present, the motions of planets, the cycles of stars, and the dynamics of galaxies all reflect the underlying temporal structure of the universe. Even the tiniest measurement of time, from an atomic clock, is connected to the broader cosmic rhythm. Our experience of seconds, minutes, and hours is embedded within a universe that has been evolving for billions of years. One of the most fascinating aspects of cosmological time is how it interacts with gravity and relativity. Massive objects, from stars to black holes, warp space-time and affect how time flows. This is why astronauts on the International Space Station age slightly more slowly than people on Earth there. Position in a weaker gravitational field and their motion relative to Earth both affect their passage of time. On cosmic scales, the warping of time becomes even more extreme near black holes or neutron stars, creating regions where time behaves in ways that seem alien to everyday experience. Cosmologists also study cosmic horizons, boundaries beyond which we cannot observe events because light from those regions has not yet reached us. These horizons create a form of temporal limitation, defining the observable portion of the universe and giving us a perspective on how time behaves on the largest scales. What lies beyond our horizon is part of the universe's history we may never see. And in this way, cosmological time is both vast and limited, stretching beyond comprehension, yet bound by the speed of light. Through all of this, it becomes clear that cosmological time is different from the human experience of time. It is measured not in hours or days, but in millions and billions of years. It is shaped by the expansion of space, the flow of entropy, and the warping of space-time itself. It reminds us that our individual lives, though precious and meaningful, occupy a fleeting moment in a universe that is unimaginably vast and ancient. As you listen and drift into relaxation, let yourself feel this cosmic perspective. Time is not only a human construct or a ticking clock, it is the unfolding of the universe itself. From the first light of the Big Bang to the farthest reaches of galaxies yet unseen. You are part of this continuum, a brief spark in the vast temporal expanse of existence. As we journey further into cosmological time, we begin to see that the universe itself follows cycles and rhythms, vast in scale and slow beyond comprehension. Stars are born, live for millions or billions of years, and eventually die, leaving behind remnants such as white dwarfs, neutron stars, or black holes. Entire galaxies collide, merge, and reshape themselves over epochs. These processes are slow, almost imperceptible from a human perspective, yet they define the unfolding story of the cosmos. The life cycle of a star is a perfect illustration of cosmic time in action. A star begins as a cloud of gas and dust collapsing under gravity. Nuclear fusion ignites at its core, converting hydrogen into helium and releasing enormous energy that lights up the star for millions or billions of years. Eventually, the star exhausts its fuel, and depending on its mass, it may shrink into a dense white dwarf, explode in a supernova, or collapse into a black hole. These transformations, measured in millions of years, show how time operates on scales far beyond our daily experience, revealing the slow, majestic evolution of the universe. Entropy. The measure of disorder continues to shape cosmological time. The universe began in a state of low entropy, highly ordered, but over time, disorder increases. Stars fuse elements, galaxies interact, and black holes absorb matter, all contributing to the gradual increase of entropy. The arrow of time, so evident in our daily lives, is mirrored on a cosmic scale, giving a directionality to the evolution of stars, galaxies, and the universe itself. This cosmic arrow reminds us that time is not merely a human perception, but a property embedded in the very fabric of reality. Cosmological time also reveals the interconnectedness of events across vast distances. Light from a supernova explosion in a distant galaxy can take millions of years to reach Earth. Yet its arrival tells a story about the past. Similarly, the cosmic microwave background, the afterglow of the Big Bang, carries information about the universe's earliest moments. By studying these signals, scientists can reconstruct the history of the cosmos, tracing the flow of time across billions of years. In this way, every observation we make is a window into the universe's temporal tapestry. Black holes, as extreme objects, demonstrate the relative nature of cosmological time. Near a black hole, gravity is so intense that it warps space-time significantly, slowing time for anything approaching it. For a distant observer, an object falling into a black hole appears to freeze at the event horizon, while for the object itself, time continues normally as it moves toward the singularity. This interplay of time, gravity, and perspective highlights the flexibility of time in extreme cosmic conditions, reminding us that even in the vast cosmos, time is not uniform. The expansion of the universe also shapes cosmological time. Galaxies are moving apart as space itself stretches, and this expansion is accelerating due to dark energy. This means that distant galaxies will eventually recede faster than light can travel, slipping beyond our cosmic horizon. In the distant future, astronomers might see only the nearest galaxies, with the rest of the universe disappearing from view. Cosmological time, then, is intimately tied to the geometry and expansion of space, shaping not only what exists, but also what can be observed. Cycles and repetition are another feature of cosmic time. Galaxies undergo mergers and interactions, stars form in bursts, and supernovae seed the cosmos with heavy elements that give rise to new stars and planets. These cycles span millions or billions of years, reflecting the slow heartbeat of the universe. Even at these vast scales, time has rhythming a reminder that the universe is not chaotic, but follows patterns shaped by gravity, motion, and fundamental laws. Cosmological time also challenges our sense of permanence. Earth and human history are mere fleeting moments in the grand scale. The solar system is about 4.6 billion years old. Yet in a few billion years, the sun will exhaust its fuel and expand into a red giant, potentially engulfing the inner planets. Our lives, civilizations, and even species are transient sparks against this immense temporal backdrop. By contemplating cosmological time, we gain perspective, understanding that our existence is a brief, delicate episode in the vast drama of the cosmos. As observers, we are intertwined with cosmic time. Every atom in our bodies was forged in stars long gone, carrying within us the history of the universe. The light reaching our eyes, the gravitational forces shaping our planet, and the expansion of space itself all link us to events billions of years in the past and millions of years into the future. In this sense, our perception of time is not separate from cosmological time, is a localized experience embedded in the universal flow. And so, as you listen and relax, imagine the universe as a vast, unfolding story. Each star, galaxy, and black hole participates in a temporal dance that stretches across billions of years. Entropy slowly increases, matter flows and transforms, and space itself expands, carrying time along with it. The universe is a living chronicle, and we, for our brief moments, are both participants and witnesses. As we continue our journey through cosmological time, it is natural to ask, what lies ahead? The universe, vast and ancient, is not static. It evolves, transforms, and ages, and the far future holds possibilities that challenge even our imagination. Scientists have proposed several scenarios, each reflecting how time itself could unfold over billions and trillions of years. One possibility is the heat death of the universe. As stars burn out, galaxies drift apart, and black holes evaporate via Hawking radiation, the universe will approach a state of maximum entropy. Energy will become evenly distributed, leaving no gradients to power change or life. In this distant, quiet future, the universe will be cold, dark, and nearly motionless. Time will continue to pass, but the events that give meaning to change the birth of stars, the merging of galaxies, the cycles of matter will become exceedingly rare. The universe will be a timeless expanse in terms of observable dynamics, a stillness stretching across unimaginable eons. Another possibility is the Big Crunch, a scenario in which the expansion of the universe eventually halts and reverses. Gravity could pull all matter and energy back together, compressing space and time toward a final singularity. In this model, cosmological time would bend, perhaps even reverse, raising profound questions about causality and the nature of beginnings and endings. Would the universe repeat itself? Could time itself cycle through infinite rebirths, with histories emerging again and again? Such ideas challenge our deepest assumptions about the linear flow of time and hint at the possibility that time may not be a simple arrow, but a more complex, perhaps cyclical phenomenon. There is also the idea of cosmic horizons, the limits of what we can observe. As space expands faster than light can travel across it, regions of the universe drift beyond our observational reach. Time beyond these horizons may continue to unfold, but it is forever inaccessible to us. From our perspective, parts of the universe are effectively frozen in mystery, existing in a kind of temporal shadow. This notion highlights the vastness of cosmological time, stretching not only into the future, but also across space we may never explore or comprehend. In contemplating these futures, we are forced to confront the scale of human existence. Our entire history, our civilizations, our triumphs and failures occupy a mere instant in cosmic time. While our lives feel rich and significant, the universe itself operates on scales so vast that our experience is fleeting. Yet, this realization can be comforting. Even as our personal timelines are brief, we are intimately connected to a larger story. Every atom in our bodies was once part of a star. Every cycle of matter and energy carries the memory of cosmic history. In this sense, humans are not separate from cosmological time. They are its brief, conscious expression. Cosmological time also reminds us of the interconnectedness of events. Supernova that occurred billions of years ago seeded the universe with elements necessary for life. The light from distant galaxies traveling across time reaches us as a bridge to the past. The gravitational pull of unseen masses shapes the motion of stars and galaxies in the present. In this sense, past, present, and future are woven together. And time is not just a measure, but a medium connecting all events across the universe, even as we contemplate the ultimate fate of the cosmos. Cosmological time has a poetic dimension. It allows us to witness cycles of creation and destruction on unimaginable scales. Stars are born and die. Galaxies collide and merge. Black holes form and evaporate. Through these processes, matter is recycled, energy redistributed, and the universe evolves. Time is the medium through which this grand narrative unfolds, carrying the story of the cosmos across billions of years. Far beyond the grasp of human experience, the study of cosmological time also shapes our understanding of our place in the universe. By appreciating the vast scales of time and space, we gain perspective on our own lives, our cultures, and our achievements. Human experience, though brief, is part of a continuum that stretches back to the first moments of the cosmos and forward to futures we may never witness. In this light, every second of conscious awareness becomes a precious opportunity to observe, reflect, and connect with the grand temporal tapestry of existence. Finally, cosmological time invites reflection on the mystery and beauty of existence. It shows us that time is not merely a human construct, but a property of the universe itself, shaping matter, energy, and the evolution of cosmic structures. From the first moments of the Big Bang to the possible heat death or cyclic rebirths of the universe, time is the silent stage upon which all events unfold. It is both vast and intimate, external yet woven into the very fabric of who we are. As you drift in the calm of the night, let yourself feel the enormity of this cosmic flow. Time stretches across galaxies and stars, across light years and eons, yet it is also the rhythm in your heartbeat, the passage of your breath, the fleeting moments of awareness. Cosmological time teaches us to see beyond the immediate, to embrace the slow, majestic unfolding of the universe, and to recognize that our lives, though brief, are inseparable from this eternal dance of time and space. Time is not a single, uniform concept. Across science, philosophy, and everyday life, there are many ways to understand it, measure it, and experience it. In this section, we will explore different types of time: physical, psychological, biological, and even theoretical, helping us appreciate the richness and complexity of this ever-present dimension. The first type is linear or chronological time. This is the time of clocks and calendars, of seconds, minutes, hours, and years. Linear time moves in a single direction from past to future, providing the structure for daily life. We use it to schedule our activities, coordinate with others, and track progress. It is measurable, objective, and consistent, at least from our everyday perspective. Linear time gives life a rhythm, allowing us to organize, plan, and remember. It is, in many ways, the type of time we are most familiar with, yet linear time is only one facet of reality. Another type is psychological time, the subjective experience of time passing. Have you ever noticed that moments of joy seem to fly by, while periods of waiting or discomfort feel endless? Psychological time is deeply influenced by attention, memory, and emotion. It can stretch, shrink, and warp depending on our experiences. For instance, a day spent immersed in creative work may feel brief, while an hour of boredom or anxiety can seem interminable. This subjective time reveals that our perception of temporal flow is not always synchronized with the steady ticking of a clock. Closely related is biological time, the internal rhythms that govern living organisms. From the human sleep-wake cycle to the migration of birds, biological time is regulated by internal clocks and external cues, such as light and temperature. The circadian rhythm, for example, is a roughly 24-hour cycle that influences sleep, hormone release, body temperature, and even mood. Beyond humans, many organisms follow seasonal cycles, adjusting reproduction, hibernation, and growth to the passage of time. Biological time connects life directly to the environment and the broader cycles of the planet, making it a dynamic and adaptive form of temporal experience. Another intriguing concept is relativistic time, introduced by Einstein's theories of special and general relativity. As we explored earlier, time is not absolute. It can slow down or speed up depending on velocity and gravity. Astronauts orbiting Earth age slightly less than people on the surface due to time dilation. And near black holes, time behaves in extraordinary ways. Relativistic time challenges our intuitive notions of a universal now, revealing that time is intimately connected with space and motion. In this sense, even the seemingly rigid framework of seconds and minutes is malleable under extreme conditions. Then there is cosmological time, the vast scale of temporal measurement in the universe. Cosmological time tracks the life cycles of stars, galaxies, and cosmic structures across billions of years. It allows us to place events such as the formation of the Milky Way or the Big Bang within a coherent timeline. Unlike linear time, which structures our daily lives, cosmological time emphasizes the enormity of the universe and the transience of human experience. It reminds us that our familiar schedules are mere blinks against the backdrop of cosmic evolution. A related concept is thermal or entropic time, tied to the second law of thermodynamics. Entropy, the measure of disorder, always increases in a closed system. This gives time a direction, the arrow of time from low entropy to high entropy. Ice melts, eggs break, stars age, and the universe expands. Entropic time provides a physical basis for the distinction between past and future, explaining why certain processes are irreversible. It is fascinating to consider that the forward flow of time we experience may emerge from this fundamental principle, shaping events across scales from molecules to galaxies. In addition to these types, philosophers and theoreticians have proposed more abstract forms. Circular time, for example, appears in certain cosmologies, myths, and philosophical systems. Time in these models is not a straight line, but a loop, with events recurring in cycles. From cosmic creation and destruction to the seasons on Earth, quantum time, explored in cutting-edge physics, suggests that at the smallest scales, time might emerge from more fundamental, timeless laws. Some theories even propose that time is an illusion, a construct arising from correlations between events rather than a fundamental dimension of reality. Each type of time offers us different lens for understanding existence. Linear time structures daily life. Psychological time shapes perception. Biological time guides living processes. Relativistic and cosmological time reveal the vastness of the universe. And entropic time explains the arrow of change. The more abstract forms, whether circular or quantum, challenge us to rethink the very nature of reality and our place within it. By recognizing these layers, we see that time is not a single thing, but a complex interplay of measurement, perception, and physical laws. Time also serves as a bridge between the human and the cosmic. While we live our lives in minutes and hours, our experiences are connected to biological rhythms and planetary cycles. On a larger scale, stars burn and galaxies collide, their histories written in cosmological time. And on the smallest scales, quantum events unfold according to principles that defy our everyday intuition. Each type of time interacts with the others, creating a rich tapestry in which human consciousness is both participant and observer. As you listen and relax, allow yourself to feel the layers of time flowing around you. The ticking seconds of your breath and heartbeat connect seamlessly with the rhythms of your biology. Beyond that, the cycles of day and night, seasons, and planetary motion echo cosmological patterns. And far beyond, the universe itself unfolds in vast, almost unimaginable spans. Time, in all its forms, is both intimate and infinite continuum in which you exist and observe. A silent rhythm accompanying every moment of awareness. Beyond the familiar divisions of time, linear, biological, psychological, and cosmological, there are more subtle and abstract ways to understand temporal experience. Philosophers, physicists, and even artists have explored these dimensions, revealing that time is as much a concept as a measurable phenomenon. One such form is experiential time, the time of consciousness and memory. Our minds do not merely register seconds and minutes. They interpret, evaluate, and construct a flow of events. When recalling memories, the past can feel vivid or distant. The future can seem near or unreachable. The richness of human experience depends on this mental construction of time. Psychological studies show that attention, emotion, and novelty strongly influence how we perceive duration. A moment of fear or anticipation can stretch into what feels like eternity, while hours of engagement in familiar tasks may pass almost unnoticed. Experiential time demonstrates that our subjective sense of the world is inseparable from our perception of temporal flow. Closely linked is cultural time, which shapes how societies organize and interpret the passage of moments. Some cultures perceive time as linear, emphasizing progress, history, and future planning. Others view time as cyclical, emphasizing seasonal patterns, rituals, and the repetition of natural and social events. Even within a single society, time can have different meanings. Work schedules, religious observances, and leisure activities all create layers of temporal understanding. Cultural time reminds us that time is not only a physical quantity, but also a social construct, negotiated and shared collectively. There is also deep time, a concept popularized by geologists and astronomers, which refers to the immensity of the Earth's and universe's history. Deep time encourages us to think beyond human scales, placing continents drifting, mountains forming, and species evolving into a continuum that spans billions of years. When we grasp deep time, our perception of personal or even civilizational duration becomes modest, almost ephemeral. Yet this awareness also creates a sense of wonder and connection, linking our lives to the unfolding story of the cosmos. Cyclic and recurring time offers another perspective. Many natural systems operate in rhythms and loops, day and night. Tides, seasons, and life cycles all repeat with predictable regularity. Ancient civilizations recognized these cycles, aligning rituals, agriculture, and storytelling with temporal patterns. Even modern science acknowledges cycles in celestial mechanics, climate systems, and biological processes. In this sense, time is not just a line, but a rhythm, a recurring beat underlying existence. Recognizing these patterns can deepen our sense of harmony with nature and the universe. Theoretical physics introduces even more intriguing concepts. Quantum time suggests that at the smallest scales, time may not flow continuously. Instead, events may occur in discrete steps, or time itself may emerge from a deeper, timeless reality. Some interpretations of quantum mechanics propose that the past and future are intertwined, with probabilities governing outcomes rather than deterministic sequences. This challenges our everyday notion of cause and effect, suggesting that the universe at its core may operate in ways that make time appear continuous only at larger scales. Block time is a related idea from the philosophy of physics. In this view, past, present, and future coexist in a four-dimensional space-time block. Events are fixed within this block, and the flow of time is a feature of consciousness, not of the universe itself. While counterintuitive, this concept aligns with certain solutions in relativity, where all points in space-time are equally real. If block time is accurate, then every moment we experience is both happening and already part of a greater continuum. Blurring the distinction between now, then, and later, time can also be understood through functional or operational perspectives. The types most relevant to daily life and technology. Clocks, calendars, and schedules impose structure on our activities, allowing coordination and predictability. Yet even operational time is flexible. Leap years, time zones, and daylight saving adjustments demonstrate that human measurement is a compromise between natural cycles and social needs. Operational time highlights the interplay between objective measures and practical necessity. Finally, personal or narrative time is the way individuals experience the story of their lives. Humans construct temporal narratives, linking past experiences to current decisions and future plans. Memory, anticipation, and imagination create a continuous sense of self over time. Narrative time shapes identity, allowing us to learn, reflect, and grow. Unlike physical or cosmological time, narrative time is deeply subjective, rich with meaning, and central to the human experience. All these types of time, physical, psychological, biological, cosmological, entropic, cyclic, quantum, block, operational, and narrative interact in complex ways. The seconds ticking on a clock, the rhythm of your heartbeat, the cycles of the planets, and the evolution of stars all coexist, overlapping and influencing perception, behavior, and understanding. Recognizing these layers enriches our appreciation of time, revealing it as a multidimensional phenomenon that transcends simple measurement. As you listen and let your mind drift, notice how different types of time resonate with your own experience. Feel the steady beat of linear time in your breathing, the flow of psychological time in your thoughts, the cycles of biological and cosmic time in the world around you. In this awareness, time becomes more than a measurement. It becomes a living, dynamic presence, connecting the personal, the planetary, and the cosmic. As we draw this exploration of time types to a close, it is important to see how they interconnect, weaving a rich tapestry that shapes both our experience and the universe itself. Each type of time, linear, psychological, biological, cosmological, entropic, cyclic, quantum, block, operational, and narrative, offers a unique lens. But together, they form a multidimensional understanding of temporal reality. Consider the interplay between linear and psychological time. While a clock measures minutes and hours consistently, your perception may stretch or compress these moments. A single second can feel fleeting during moments of joy or eternity during moments of stress. This subjective experience does not negate the linear passage of time, but adds depth, reminding us that measurement alone cannot capture the full richness of temporal reality. Similarly, biological and operational time intersect continuously. Your body follows circadian rhythms and metabolic cycles that govern sleep, alertness, and energy. Yet you structure your day around operational time appointments, work schedules, and social interactions. Often, these layers are misaligned, such as when jet lag or shift work disrupts internal rhythms. Observing this interaction demonstrates that time is experienced on multiple scales simultaneously: internal, external, and socially constructed. On a larger scale, cosmological and entropic time remind us that human experience is nested within a broader universal framework. Stars live and die, galaxies collide, and entropy increases relentlessly. These processes unfold over billions of years, dwarfing the linear seconds and minutes of daily life. Yet, even at this cosmic scale, the principles of change, causality, and rhythm remain. Time, from the smallest moment to the age of the universe, is a continuous flow of transformation and evolution. Theoretical and philosophical forms of time, such as quantum and block time, challenge our intuition. If the universe at its core operates on probabilities or exists as a four-dimensional space-time block, then the flow of time we perceive may be emergent rather than fundamental. This does not make our experiences any less real. Rather, it situates them within a deeper, more complex reality. The seconds you perceive, the thoughts you have, and the memories you recall are all part of a larger, multidimensional structure where time can be both continuous and discrete, dynamic and fixed. Cyclic and recurring time offer yet another perspective, emphasizing repetition and rhythm. From planetary orbits to ecological cycles, patterns recur across scales, linking human experience to planetary and cosmic cycles. Ancient civilizations observed these rhythms and structured their calendars, rituals, and storytelling accordingly. Recognizing cycles in modern science and daily life allows us to appreciate continuity, harmony, and the predictability inherent in natural systems. Ultimately, all types of time converge in the human mind as narrative time. We construct stories from our experiences, linking past, present, and future into a coherent sense of self. Narrative time is subjective, meaning-rich, and deeply intertwined with consciousness. It allows us to reflect, plan, imagine, and grow. Yet it is always in dialogue with physical, biological, and cosmic time. The seconds of a clock, the cycles of the body, and the age of the stars all inform the narratives we create, subtly shaping our perception of past, present, and future. Reflecting on these multiple types of time encourages a sense of humble awareness. Human experience, while fleeting, is deeply connected to rhythms and processes far larger than ourselves. Each heartbeat, thought, and action is a moment within a continuum that stretches from the first fractions of a second, after the Big Bang, to potential futures beyond imagination. Time is not a single dimension, but a multi-layered phenomenon that links our personal existence to the broader cosmos. As you listen and allow your mind to relax, imagine yourself moving through these layers of time. Feel the ticking seconds of linear time, the rhythms of your body and mind, and the unfolding of cosmic events far beyond your immediate perception. Sense the subtle interplay of cycles, probabilities, and narratives that shape existence on every scale. Time is at once measurable and mysterious, subjective and universal, fleeting and eternal. In this awareness, we find a connection between the personal and the cosmic, the immediate and the eternal. Each type of time offers a window into reality, and together they provide a more complete understanding of the universe and our place within it. Time is both the stage and the story, the medium and the motion, the observer and the observed. By contemplating its many forms, we expand our perception, deepen our understanding, and cultivate a profound sense of wonder as you drift into calm. Let yourself exist within all these layers of time simultaneously. Feel the heartbeat of linear time, the flow of consciousness, the cycles of biology and nature, the enormity of cosmological evolution, and the mysterious depths of theoretical and quantum time. Every moment, every breath, every thought is a point where these dimensions intersect, reminding us that we are both transient and eternal, fleeting and timeless, present and infinite. Welcome back to Science While You Sleep. As you settle into a calm and restful state, let us gently guide you into the fascinating world of time perception and the human brain. Time, as we have explored, is not only a physical or cosmic phenomenon, is also a deeply personal experience shaped by the intricate workings of the mind. Understanding how our brains perceive time can reveal profound insights into consciousness, memory, and human experience. The first thing to realize is that time is not directly sensed like sight or sound. Our brains do not have a dedicated time receptor in the way we have eyes to perceive light. Instead, time perception emerges from the coordinated activity of multiple neural systems. These systems monitor changes in the environment, process sensory information, and integrate memory and anticipation to create a continuous sense of temporal flow. In essence, time is a construct of the brain, a mental framework allowing us to organize events, plan actions, and navigate our world. One critical aspect of time perception is duration estimation, the ability to judge how much time has passed. This ability varies depending on context, attention, and emotional state. For example, when you are fully absorbed in an engaging activity, minutes can seem to vanish, while waiting anxiously for something can make seconds drag endlessly. Neuroscientists believe this is due to variations in neural activity in regions such as the basal ganglia, cerebellum, and prefrontal cortex, which work together to measure intervals and synchronize internal timing mechanisms. Memory plays a central role in perceiving the passage of time. Our sense of the past depends on episodic memory, the mental record of experiences. When recalling events, the richness and detail of memory influence our perception of how long ago something occurred. Emotional intensity can further distort temporal perception. Highly emotional experiences often feel longer in retrospect, while mundane or repetitive events may seem to compress into a brief span. The brain, in this way, shapes subjective time as a combination of memory, attention, and emotion. Another fascinating aspect of time perception is temporal binding, the brain's ability to link events across time into coherent sequences. When you hear a sound and see a visual cue in quick succession, your brain merges them into a single event. This mechanism allows us to perceive causality and narrative, giving continuity to our experience. Without temporal binding, events would appear fragmented, and our understanding of cause and effect would break down. It is this seamless integration that makes time feel fluid rather than disjointed. Circadian rhythms, which regulate our biological clocks, also influence our experience of time. The suprachiasmatic nucleus in the hypothalamus acts as a master clock, coordinating daily cycles of sleep, hormone release, and alertness. When these rhythms are disrupted by jet lag, shift work, or irregular sleep, our perception of time can feel distorted. Seconds may feel longer or shorter, and the flow of the day can become disorienting. In this way, the body and brain work together to create a stable temporal framework. Attention is another key factor. Studies have shown that when people focus intently on a task, they often underestimate the passage of time, whereas distraction or boredom can cause overestimation. This suggests that time perception is not constant but modulated by cognitive load and focus. The brain allocates resources differently depending on engagement, making time feel faster or slower. Even subtle shifts in attention can change the subjective experience of moments, illustrating the pliable and dynamic nature of temporal perception. Neurological disorders provide further insight into the brain's role in time. Conditions such as Parkinson's disease, schizophrenia, and attention deficit disorders often disrupt temporal processing. Patients may struggle to estimate durations accurately, perceive events in the wrong sequence, or experience altered rhythms of action and thought. Studying these conditions helps scientists understand how the brain constructs time, revealing which neural networks are essential for maintaining a coherent temporal experience. Emotional states are deeply intertwined with temporal perception. Fear, anxiety, joy, or sadness can warp the passage of time, making moments feel longer or shorter than they actually are. This is often linked to the amygdala, which processes emotion, and its interaction with memory and attention systems. When emotions heighten, the brain records more information, making experiences seem richer and, in retrospect, longer. Conversely, mundane or predictable events may be compressed, creating the illusion that time passes quickly during routine activities. Music, rhythm, and movement offer another window into time perception. Engaging with rhythmic patterns can synchronize neural activity, creating a shared sense of temporal flow. Musicians, dancers, and athletes often develop heightened sensitivity to timing, able to anticipate beats and coordinate actions with extraordinary precision. This sensitivity reflects the brain's ability to internalize time and use it to structure both perception and action, linking temporal awareness directly to skill, creativity, and bodily coordination. Finally, meditation and mindful awareness can transform our experience of time. Studies suggest that focusing attention on the present moment can expand subjective time, making each second feel fuller and more vivid. Conversely, habitual distractions and multitasking often compress temporal awareness, leaving days and weeks feeling as if they passed in a blur. By cultivating mindfulness, we can explore the elasticity of time perception and appreciate its role in shaping conscious experience. As you relax and drift deeper into a state of calm, imagine your brain quietly measuring, integrating, and interpreting countless signals. Every beat of your heart, every shift of attention, every memory recalled or imagined contributes to the sensation of time flowing around you. Notice how seconds stretch and compress, how past, present, and future coexist in your awareness, and how your perception of time is both personal and universal. As we continue to explore how the human brain perceives time, it becomes clear that our experience of temporal flow is both complex and malleable. The brain does not passively record time. It actively constructs it, using a network of neural systems to interpret, predict, and integrate events. At the center of this network is the basal ganglia, a set of structures deep within the brain that help regulate movement and interval timing. These structures work in concert with the cerebellum, which fine-tunes motor coordination and anticipates the precise timing of actions. Together, they allow us to perform tasks that require temporal accuracy, such as speaking, playing music, or catching a ball. The basal ganglia also influence how we perceive the duration of intervals, forming the foundation for our sense of rhythm and sequential order. The prefrontal cortex, responsible for higher-level cognitive functions, is essential for planning, decision-making, and temporal organization. It integrates sensory information, memories, and predictions, helping us anticipate future events and evaluate the consequences of our actions. This region allows humans to think abstractly about time, imagine scenarios, and make choices based on future outcomes. It is the neural basis for foresight, goal-directed behavior, and the ability to mentally travel through time in imagination or memory. The hippocampus plays a key role in episodic memory, which connects past experiences to the present moment. By recalling the sequence and context of past events, the hippocampus contributes to our understanding of how time flows. It allows us to place experiences on a mental timeline, constructing a coherent narrative of life. This function is closely linked to our sense of self, as memory and identity are deeply intertwined with temporal awareness. Illusions of time provide fascinating insight into the brain's temporal processing. One such illusion is the time dilation of fear or surprise, where moments of intense emotion seem to stretch longer than they objectively are. The brain heightens attention, records more details, and intensifies memory encoding during these events. Retrospectively, these moments feel prolonged because of the richness of information stored. Conversely, routine or repetitive experiences may feel compressed, as the brain filters out predictable information, creating the sensation that time is passing quickly. Another phenomenon is the chronostasis effect, commonly experienced when looking at a clock immediately after shifting gaze. The first second appears longer than the following seconds, as the brain retroactively adjusts perception to maintain continuity. This demonstrates that the brain constructs temporal experience dynamically, filling in gaps and smoothing transitions to create the illusion of a seamless flow. Attention continues to play a central role. When focus is intense, the brain may undercount the passage of time, while distraction or stress can lead to overestimation. Research shows that dopamine, a neurotransmitter associated with reward and motivation, influences these processes. High dopamine activity tends to speed up the internal clock, making intervals feel shorter, whereas low dopamine slows it down. This explains why engaging activities seem to make time fly, while boredom stretches it endlessly. Neurological disorders further illuminate the mechanisms of temporal perception. Patients with Parkinson's disease, which affects the basal ganglia, often struggle to estimate durations accurately and experience disrupted rhythmic timing. Individuals with schizophrenia may perceive events in altered sequences, leading to difficulties in distinguishing cause and effect. Studying these conditions allows scientists to identify the neural networks responsible for timing, sequence integration, and the subjective sense of temporal flow. The interaction between memory and anticipation is another critical aspect. The brain constantly predicts the future based on past experiences, creating a dynamic interplay between what has happened and what might occur. This predictive processing allows humans to adapt, learn, and respond to complex environments. It also shapes subjective time. When predictions are accurate and events unfold as expected, time feels smooth and continuous. When surprises occur, time perception is altered, highlighting the brain's role in constructing temporal reality. Music, rhythm, and dance demonstrate the practical application of these mechanisms. Musicians synchronize movements and anticipate beats through finely tuned neural timing systems. Dancers coordinate complex sequences with rhythmic precision, while athletes anticipate dynamic changes in their environment. In each case, the brain integrates sensory input, motor planning, memory, and attention to create a cohesive temporal experience, linking internal perception with external events. Finally, meditation and mindfulness practice reveal that time perception is not fixed but can be trained. Focusing attention on the present moment expands subjective awareness, making each second feel fuller and more vivid. This intentional engagement with the flow of time contrasts with habitual distraction, where days and weeks seem to pass unnoticed. By cultivating mindfulness, individuals gain insight into the elasticity of temporal perception and the profound role consciousness plays in shaping time. As you relax and drift deeper, let yourself feel the subtle operations of your brain, quietly measuring, predicting, and integrating events. Notice how attention, memory, and emotion shape the sensation of time passing. Feel the rhythm of your body, the cycles of your mind, and the neural orchestration that creates the flow of seconds and moments. In this awareness, you experience time not as an abstract measure, but as a living, dynamic part of your conscious experience, intimately connected to thought, feeling, and perception. As we reach the final part of our exploration of time's influence on humans, let us consider the broader long-term effects of time, how it shapes life's perspective, and ways we can harmonize with its flow for greater well-being and awareness. One of the most profound aspects of time's impact is the shaping of long-term life perspective. From childhood through old age, humans construct narratives of their lives that are deeply temporal. Early experiences influence identity and perception. Adolescence expands awareness of possibilities. Adulthood introduces responsibilities and long-term planning. And later years bring reflection on achievements, regrets, and the passage of life itself. This temporal scaffolding allows for meaning-making, connecting individual moments into coherent life stories. By understanding these patterns, we can better navigate transitions, set goals, and appreciate the arc of our existence. Temporal perspective affects mental health and resilience. Individuals with a balanced awareness of past, present, and future often experience greater emotional stability. Reflecting on past experiences with insight and acceptance allows for learning without being trapped in regret. Focusing on the present enhances mindfulness and appreciation, while anticipating the future encourages planning, motivation, and hope. Conversely, overemphasis on any single temporal dimension can lead to anxiety, nostalgia, or disconnection. Awareness of temporal balance, therefore, is key to psychological well-being. Time also exerts influence on physical health through long-term rhythms and habits. Sleep patterns, circadian alignment, dietary routines, and activity cycles shape biological aging and resilience. Chronic disruption of these patterns, whether through irregular schedules, stress, or environmental factors, can accelerate health decline and reduce cognitive function. Understanding and harmonizing with natural temporal cycles allows for improved vitality, focus, and longevity, demonstrating that time is not only an abstract concept, but a tangible force acting on our bodies, memory, and temporal awareness shape, decision-making, and goal-setting. Humans project into the future to plan, anticipate consequences, and strategize, while drawing on past experience to learn and adapt. This interplay between memory and foresight is essential for personal growth, career development, and relationships. Time awareness also encourages ethical and social reflection, reminding us that our actions resonate beyond the immediate moment, influencing both our own lives and the lives of others over extended periods. Culturally, humans create rituals and traditions to anchor temporal experience. Annual festivals, anniversaries, and rites of passage provide structure, continuity, and shared meaning. These rituals reinforce social bonds, offer comfort, and mark transitions in a way that aligns individual experience with collective temporal rhythms. Participation in such temporal practices allows humans to feel connected to past generations, present communities, and future legacies, highlighting the interplay between personal and societal perception of time. Another critical aspect is the subjective acceleration of time with age. While years may pass uniformly, the experience of time often feels faster as one grows older. Novelty, engagement, and attention modulate this perception. By intentionally seeking new experiences, practicing mindfulness, and remaining attentive to the present, individuals can expand their subjective experience of time, making life feel fuller and more vivid. This awareness encourages intentional living, helping us prioritize meaningful moments over trivial routines. Humans also respond to the psychological effects of mortality. Awareness of finite time shapes values, priorities, and motivation. Existential reflection, often prompted by life transitions or contemplation of mortality, encourages introspection and fosters a sense of urgency, gratitude, and purpose. Fiction, philosophy, and art often explore these themes, allowing humans to mentally rehearse, reflect, and derive insight from imagined or symbolic temporal experiences. Time, in this sense, is both a challenge and a guide, influencing how life is approached and valued. Finally, humans can harmonize with time through mindfulness, awareness of natural rhythms, and intentional engagement with the present. Practices such as meditation, focused attention, and reflection cultivate a deeper sense of temporal flow, reducing stress and enhancing emotional well-being. Aligning daily routines with biological and environmental cycles, embracing novelty, and appreciating meaningful moments allows individuals to experience time as expansive rather than constraining. Even while resting or sleeping, the body and mind continue to interact with time, consolidating experiences, regulating internal rhythms, and preparing for future engagement. As you listen and drift into deeper relaxation, visualize the gentle, expansive flow of time within and around you. Feel the heartbeat as a temporal anchor, the breath as a rhythm of continuity, and the unfolding moments as threads weaving the tapestry of your life. Every memory, anticipation, and sensation exists within this temporal landscape, shaping perception, emotion, and behavior. Recognize that time is not an enemy or a limit, but a medium through which experience, learning, and growth unfold. In this state, let your mind and body synchronize with the cycles of time, resting, rejuvenating, and integrating the lessons of past, present, and future through awareness, reflection, and intentional engagement. Humans can live harmoniously with time, appreciating each moment while embracing the flow of life. By understanding its influence on cognition, emotion, behavior, and health, we gain insight into how to navigate existence with clarity, balance, and serenity. Even in rest, time shapes us, guiding adaptation, reflection, and growth, demonstrating that our experience of life is inseparable from the continuous, subtle, and profound passage of time. Continuing our exploration, let us delve deeper into how time shapes human perception, behavior, and mental states, revealing the subtle ways in which temporal awareness influences every aspect of our lives. The human brain does not perceive time as a constant. Instead, it interprets it relative to attention, novelty, and emotional engagement. Psychologists and neuroscientists have shown that heightened attention or intense experiences can make moments feel longer, while routine or repetitive tasks compress our sense of duration. This is why joyous events often seem to pass quickly, and stressful or mundane moments feel prolonged. The elasticity of perceived time reflects the intimate link between consciousness and temporal experience, illustrating that our internal clocks are as dynamic as the universe itself. Circadian rhythms, the natural, roughly 24-hour cycles of physiological processes, play a central role in synchronizing our bodies with the external world. These rhythms regulate sleep, hormone production, body temperature, and alertness, creating a temporal harmony between internal biology and the passage of external time. Disruptions to circadian rhythms, such as shift work, jet lag, or artificial lighting, can profoundly affect mood, cognition, and overall health. In essence, the brain and body are deeply entwined with time, responding to its cycles even when we are not consciously aware. Beyond circadian rhythms, humans possess ultradian and infradian rhythms, shorter and longer cycles that affect attention, hormone fluctuations, and physiological states. Ultradian rhythms, which occur every 90 to 120 minutes, influence alertness and cognitive performance, creating natural peaks and troughs in energy and focus. Infradian rhythms, such as menstrual cycles, influence longer-term patterns in physiology and behavior. Awareness of these temporal cycles can enhance well-being, productivity, and emotional balance, offering insight into how internal time interacts with the external flow of hours, days, and seasons. Time profoundly shapes learning and memory. The hippocampus and prefrontal cortex encode experiences within a temporal framework, allowing humans to organize past events, anticipate outcomes, and plan future actions. Our perception of temporal order enables narrative construction, causal reasoning, and problem-solving. Without this temporal scaffolding, memory would be a chaotic collection of disjointed moments, and decision-making would lose coherence. Time, therefore, is not merely a background metric, but an active component of cognitive function, structuring thought and experience. Emotional processing is intimately linked to time perception. Anticipation, regret, nostalgia, and hope are all temporal experiences, reflecting our awareness of past, present, and future. The ability to project forward allows planning and foresight, while reflecting backward provides learning and personal growth. Stress and anxiety often arise when temporal expectations clash with reality, such as when deadlines loom or uncertain futures create apprehension. Conversely, mindfulness practices, which focus attention on the present moment, can recalibrate temporal perception. Reducing stress and enhancing well-being, the aging process illustrates another dimension of time's impact. Perception of time often accelerates with age. A phenomenon linked to the proportionality of life experience year becomes a smaller fraction of total lived experience. Novelty, attention, and memory can modulate this perception, explaining why new experiences make time feel expansive while routine compresses its subjective flow. This dynamic underscores how subjective time shapes experience as profoundly as chronological time. Social structures and cultural rhythms are also intertwined with human time perception. Societies coordinate through shared calendars, work schedules, and cultural rituals, reinforcing temporal norms. These collective rhythms influence individual behavior, emotions, and social interactions. Observing birthdays, anniversaries, and seasonal festivals provides continuity and cohesion, reminding us that human experience of time is both personal and communal. Shared temporal frameworks allow societies to function smoothly while shaping individual perception and expectations. Technological environments further influence our temporal experience. Digital media, constant notifications, and rapid communication create a sense of temporal compression, where events and information arrive faster than our cognitive systems can process. This acceleration can induce stress and reduce attention span, while paradoxically increasing the perception of wasted or fleeting time. Understanding these influences highlights the importance of balancing technology with awareness of natural temporal rhythms. As you relax, imagine the gentle, ongoing dance of time within your own body and mind. Feel the rhythmic flow of breath, the heartbeat marking each moment, and the subtle unfolding of seconds, minutes, and hours. Notice how your memories, anticipations, and reflections are all situated within this temporal framework, shaping your emotions, cognition, and well-being. Even as you drift into deeper rest, your body and mind remain harmonized with the cycles of time, demonstrating its pervasive influence. Time's impact on humans is profound and multi-layered, encompassing physiological cycles, cognitive processes, emotional experience, and social structures. By observing these patterns, we gain insight into the delicate interplay between internal and external time, learning how to navigate life more mindfully and harmoniously. Awareness of temporal influence allows for healthier rhythms, deeper reflection, and a richer appreciation of each passing moment. Continuing our exploration of time travel in fiction, we now dive deeper into the narrative devices and paradoxes that authors use to create compelling stories, as well as the emotional resonance these stories evoke in readers and viewers. One of the most captivating devices in fictional time travel is the alternate timeline or parallel universe. When characters change the past or make pivotal decisions, authors often explore the consequences in a separate, divergent reality. This allows narratives to experiment with what-if scenarios, imagining how small variations can drastically alter society, culture, or personal destiny. For example, a single choice by a character might lead to a utopian future, a dystopian collapse, or entirely unforeseen developments. Through these narrative structures, fiction mirrors the branching possibilities of life itself, engaging our imagination while reflecting on the complexity of cause and effect. Time loops remain another powerful storytelling tool. Beyond comedic or dramatic repetition, loops allow characters to learn, adapt, and grow. Each iteration offers subtle changes that reveal new facets of personality, circumstance, or morality. In some narratives, loops serve as metaphors for reflection, habit, or psychological states, demonstrating that time travel in fiction is as much about internal exploration as external movement. Audiences are drawn into this iterative process, experiencing temporal elasticity alongside the characters, feeling the subtle tension and release of repeated moments. Paradoxes often become central to fictional tension. The grandfather paradox or similar causal dilemmas challenge characters to navigate the consequences of altering events. Authors use these paradoxes not only to create suspense, but also to explore ethical and philosophical questions. What is the responsibility of someone who can change the past? Can one prevent disaster without unintended consequences? In navigating these challenges, characters and, by extension, audiences confront the moral and emotional dimensions of choice, consequence, and the fragility of time. Predestination paradoxes are also common in time travel narratives. In these stories, attempts to change the past inadvertently bring about the very events the character seeks to prevent. This creates a loop of inevitability, highlighting the tension between free will and fate. Such narratives invite reflection on the balance between action and consequence, and on the paradoxical nature of temporal causality. They demonstrate that even when time travel is possible in fiction, the universe of the story often maintains coherence, preventing truly chaotic outcomes while exploring dramatic possibilities. Authors often experiment with nonlinear storytelling, presenting events out of chronological order to mimic the fluidity of time travel. By showing future events before past causes or interweaving multiple timelines, narratives evoke a sense of temporal dislocation and wonder. Readers experience time as flexible, layered, and multidimensional, mirroring the subjective perception of time we explored earlier in our discussions on human cognition. This approach encourages deep engagement, requiring the audience to actively construct meaning from the narrative's temporal architecture. Emotional stakes are heightened through time travel. Characters confronting lost love, historical tragedy, or future catastrophe evoke profound empathy. The ability to move through time allows exploration of regret, redemption, and hope. In some stories, revisiting past mistakes provides characters with growth and understanding. In others, glimpsing the future motivates action in the present. Fictional time travel thus serves as a mirror to the human experience, showing how temporal awareness shapes identity, values, and emotional depth. Cultural and historical exploration is another rich aspect. Time travel enables narratives to immerse characters in distinct eras or civilizations, revealing contrasts in technology, society, and morality. By experiencing historical or speculative futures, characters and audiences gain perspective on the continuity and evolution of human experience. This narrative device also allows reflection on the cyclical nature of history, the consequences of human choices, and the persistent questions of morality, justice, and survival across time. Finally, fiction often emphasizes the imaginative freedom of time travel. Unlike science, which is constrained by empirical laws, fiction allows temporal rules to be bent, broken, or reimagined entirely. Characters may communicate with their past selves, exist in multiple eras simultaneously, or perceive all moments at once. These imaginative possibilities create narratives that are not only entertaining but thought-provoking, offering insight into human curiosity, the desire for exploration and the fascination with the unknown as you drift deeper into relaxation. Allow your mind to journey alongside these stories. Imagine stepping into alternate realities, revisiting pivotal moments, or witnessing future possibilities unfold. Feel the tension of paradoxes, the fluidity of loops, and the profound emotional resonance of temporal journeys. In this state, time becomes playful, flexible, and richly textured, a landscape of imagination and reflection where every choice, every moment, and every possibility exists simultaneously. As we complete our journey through the scientific possibilities of time travel, let us explore the cosmological and philosophical dimensions, along with the speculative technologies that push the boundaries of imagination. One fascinating avenue is cosmological time travel, which considers the structure of the universe itself. Certain solutions to Einstein's field equations suggest that rotating or expanding universes might permit closed time-like curves. In these models, the shape and dynamics of spacetime could allow travel to past or future moments under precise conditions. Though these scenarios are theoretical, they demonstrate that time is woven into the very fabric of the cosmos, and its flow is not universally uniform. Regions of spacetime may experience differing temporal dynamics, offering a glimpse of the extraordinary diversity of temporal experience on a cosmic scale. Speculative technologies also offer imaginative pathways. Time dilation vehicles are one concept, envisioning spacecraft traveling at relativistic speeds, where astronauts experience days while decades pass on Earth. While such journeys are currently beyond our propulsion capabilities, they remain grounded in tested physical principles. Artificial gravity wells or rotating space habitats could, in theory, induce localized time dilation effects, subtly altering temporal experience for occupants. Even without traversing to the past, these devices could allow humans to explore the elasticity of time through controlled environments. Another intriguing idea involves exotic matter and negative energy to stabilize wormholes or manipulate spacetime for temporal travel. Physicists theorize the need for matter with negative energy density. Though unobserved at macroscopic scales, negative energy appears in quantum phenomena such as the Casimir effect, where energy fluctuations create attractive forces between plates. While the amounts are minuscule, these phenomena suggest that the universe contains ingredients that could, in principle, allow exotic manipulations of time. Time travel also intersects with entropy and the arrow of time. In classical physics, entropy disorder tends to increase, giving time its apparent direction. Any backward movement through time would require mechanisms that locally increase entropy without violating thermodynamic laws. This challenge is not merely technical, but deeply conceptual, as it touches the fundamental link between time, energy, and the evolution of the universe. Understanding this relationship may reveal why we experience a forward flow and whether exceptions are theoretically possible. Philosophically, time travel provokes questions about determinism, free will, and causality. If one could travel to the past, would events be fixed, allowing only self-consistent actions? Or could history be altered, creating branching realities? Could knowledge of the future influence choices, and how would that affect our understanding of responsibility and agency? These reflections remind us that time is not only a scientific variable, but also a deeply human experience, intertwined with perception, memory, and decision-making. Even as we examine speculative mechanisms, it is important to note that current experimental evidence supports only forward time travel at practical scales. Astronauts moving at high speeds or in strong gravitational fields experience slight time dilation relative to observers on Earth, confirming that time can be stretched but not yet reversed. These examples are modest compared to the science fiction scenarios, yet they illustrate that the principles underlying time travel are embedded in reality, waiting to be explored further as technology advances. The interplay between quantum mechanics and general relativity remains the frontier for time travel research. Reconciling these two pillars of physics may unlock new insights into temporal manipulation. Concepts such as quantum loops, entanglement across time, and retrocausal influences suggest that time may behave differently at microscopic scales, while macroscopic backward travel remains speculative. The microcosmic behavior of time challenges our intuitive understanding, hinting at a universe more flexible and intricate than our ordinary experience suggests. Finally, consider the experience of time travel in consciousness. Even without machines, the mind can simulate journeys through time. Memory allows us to revisit the past, imagination projects us into the future, and dreams often bend temporal sequences. These mental voyages demonstrate that time travel, in a subjective sense, is already part of human experience. The brain constructs temporal realities, allowing us to explore, anticipate, and reflect, providing a bridge between scientific theory and personal perception as you drift into deeper relaxation. Imagine gliding alongside space-time, watching the cosmos unfold at varying speeds. Picture wormholes stretching like shimmering tunnels, stars warping time around their gravity wells, and quantum particles dancing across possibilities. Feel the gentle expansion and contraction of moments, the interplay of past, present, and future, and the elegance of a universe where time is both structured and flexible. Even as you rest, your mind participates in this cosmic exploration, witnessing the profound mysteries of time and the tantalizing possibilities of traversing its depths in this state of calm and contemplation. Remember that time travel is more than science fiction. It is a window into the fundamental nature of reality. By studying relativity, quantum mechanics, and cosmology, we glimpse how time might be bent, stretched, and navigated. Through imagination, thought experiments, and subtle real-world effects, humanity continues to explore the boundaries of temporal experience, guided by curiosity, wonder, and the profound desire to understand the fabric of existence. Welcome back to Science While You Sleep. Now that we have explored the perception and experience of time, let us gently drift into one of the most fascinating frontiers: time travel. For centuries, humans have imagined moving backward or forward through time. And while it has long been the domain of science fiction, modern physics offers intriguing possibilities that invite both wonder and contemplation. Time travel, at its core, challenges our intuitive understanding of linear time. In everyday life, time seems to flow in one direction from past to present to future. However, theoretical physics suggests that the arrow of time may not be so absolute. Einstein's theory of relativity demonstrates that time is intertwined with space, forming a four-dimensional fabric known as spacetime. This union of space and time implies that under certain extreme conditions, the passage of time can vary, and the potential for movement across temporal coordinates becomes more than mere imagination. One of the most well-known implications of relativity is time dilation, a phenomenon confirmed through experiments with highly precise clocks. When objects move at speeds approaching the speed of light, time for those objects slows relative to stationary observers. Astronauts aboard high-velocity spacecraft would experience minutes passing while hours or years elapse for people on Earth. This effect, though subtle at everyday speeds, is real, measurable, and a form of forward time travel, allowing future moments to arrive more slowly for the traveler than for those left behind. Gravity, too, influences time. Einstein's general relativity predicts that strong gravitational fields slow the passage of time, a phenomenon known as gravitational time dilation. Near a massive object such as a black hole, time stretches. An observer far from the mass would perceive events near the black hole as unfolding more slowly. In this sense, deep space environments provide natural laboratories for experiencing variations in the flow of time. demonstrating that the universe itself contains mechanisms for what we might call time travel, even if only forward in time. Wormholes, often called Einstein-Rosen bridges, are theoretical shortcuts through space-time that could, in principle, allow instantaneous travel between distant points in space. Some physicists speculate that if one mouth of a wormhole experienced significant time dilation relative to the other, it could function as a portal to the past or future. While purely speculative and currently beyond our technological reach, these models provide a scientific framework for imagining time travel beyond the speed of light limitations of conventional space. Another intriguing concept is the Tipler cylinder, a theoretical solution to Einstein's equations. This model involves a massive, infinitely long, spinning cylinder, which warps spacetime around it in a way that could, theoretically, create closed time-like curves paths that loop back in time. While the physical realization of such a structure is far beyond current capabilities, it demonstrates that, mathematically, the laws of physics allow for scenarios in which time loops might exist. Quantum mechanics adds further complexity to the idea of time travel. Some interpretations suggest that particles can exist in superpositions across time, and that events may not follow a single, deterministic path. Concepts such as retrocausality, where future events influence the past, remain highly theoretical but provoke deep questions about causation, temporality, and the nature of reality. If time is more fluid at the quantum scale, it may be possible to imagine scenarios where information or even energy moves backward in time without violating physical laws. Of course, time travel raises the possibility of paradoxes, which challenge both logic and physics. The classic grandfather paradox imagines traveling back in time and preventing your own existence. Some theoretical models, such as the Novikov self-consistency principle, suggest that the universe may forbid paradoxical actions, ensuring that any attempt to change the past would be consistent with history as it already occurred. In other words, time might be flexible but self-protective, allowing travel without logical contradictions. Cosmologists also explore closed time-like curves in the context of rotating black holes or certain space-time geometries. These solutions imply that paths looping back through time are mathematically possible, though the energy conditions and stability requirements make them speculative. Nonetheless, they expand our understanding of time, suggesting that under extreme conditions, the separation between past, present, and future may not be as absolute as it seems, even without traversable wormholes or cosmic cylinders. Technologies on Earth demonstrate small-scale time travel effects. Atomic clocks flown in airplanes or satellites have confirmed relativistic time dilation, requiring adjustments in GPS satellites to maintain accuracy. In essence, the satellites experience time slightly differently than people on Earth, and without correction, navigation systems would drift. This is a practical, everyday example of humanity harnessing relativistic effects to manipulate the flow of time, however subtly. Time travel, therefore, is not merely fantasy. It is grounded in the mathematical and physical structure of the universe. While human journeys into the distant past remain beyond reach, forward time travel, time dilation, and the manipulation of temporal perception are real phenomena. Scientists continue to probe these possibilities, exploring both theoretical models and experimental valdics. As you drift deeper into relaxation, imagine floating alongside space-time itself, feeling its curves, bends, and stretches. Picture yourself near a massive star, where moments slow, or hurtling at near light speed, where seconds stretch into hours. Let the mind explore these possibilities gently, without tension, marveling at the universe's subtle mechanisms that allow time to flow differently in different places. Even as you rest, your consciousness can witness the flexibility, the wonder, and the profound beauty of time's nature. As we conclude our journey through time perception, 'tis fascinating to explore how the brain can stretch, compress, and even distort the experience of temporal flow under various conditions. These phenomena reveal both the flexibility and the sophistication of neural timing mechanisms. One remarkable example is the perception of time under extreme stress or danger. During life-threatening situations, people often report that events seem to slow down, allowing them to react with heightened awareness. Neuroscientists believe this effect results from increased arousal and enhanced sensory processing. The amygdala, responsible for emotional processing, heightens attention to detail, while the hippocampus encodes memories with greater richness. Retrospectively, these moments seem elongated because the brain has recorded an unusually high density of information. It is as if the mind expands time to give the body a better chance of survival. In contrast, repetitive or monotonous activities often cause time to feel compressed. The brain tends to filter out predictable information, focusing only on changes or novel events. As a result, hours of routine work or travel can feel like minutes in retrospect. This selective attention allows the brain to conserve resources, but also demonstrates that our perception of time is not constant text, novelty, and cognitive engagement. Aging also influences temporal perception. As people grow older, many report that time seems to pass more quickly. Several explanations have been proposed. The proportional theory suggests that each year becomes a smaller fraction of total life lived, making it feel shorter. Others point to decreased novelty and routine experiences, which reduce the density of memorable events. Neuroscientifically, changes in neuroplasticity and processing speed may subtly alter internal timing mechanisms. This dynamic interplay between physiology, memory, and experience illustrates how perception of time evolves across a lifespan. The brain also exhibits adaptive temporal mechanisms. For instance, when exposed to environments with altered cassutes, such as darkness, isolation, or virtual reality, our perception of time can shift to match new circumstances. In these situations, internal clocks adjust, recalibrating attention, memory encoding, and anticipatory processes. This adaptability ensures that temporal perception remains functional even when external markers of time are absent or distorted. Temporal illusions further highlight the brain's construction of time. The stopped clock illusion, for example, occurs when we first glance at a clock. The first second appears longer than it actually is. The oddball effect is another fascinating phenomenon, where novel or unexpected stimuli are perceived to last longer than repeated or familiar events. These illusions reveal that time perception is not a passive recording, but an active interpretation, shaped by attention, expectation, and novelty. Interestingly, dreams and altered states of consciousness provide a window into subjective time. During dreams, events can unfold in sequences that feel both immediate and extended, often violating the linearity of waking time. The brain simulates experiences, emotions, and narratives, creating a temporal reality independent of clocks. Similarly, meditation, hypnosis, and certain psychoactive experiences can expand or contract perceived duration, demonstrating the profound influence of cognitive states on temporal. Awareness time perception also affects decision-making and behavior. Humans often weigh immediate rewards against delayed outcomes, a process known as temporal discounting. The subjective experience of time shapes choices, risk assessment, and planning. When time feels compressed, long-term consequences may seem less significant. When time feels elongated, future possibilities can gain prominence. Understanding these mechanisms is crucial not only for psychology, but also for education, economics, and social behavior. Furthermore, cultural factors continue to shape temporal perception. Societies emphasizing punctuality and efficiency train attention and expectation in specific ways, whereas cultures with more flexible temporal frameworks encourage a different pacing of experience. These differences interact with individual neural mechanisms, highlighting that perception of time is simultaneously biological, psychological, and social. Finally, let us consider the harmonization of all these mechanisms. The brain continuously integrates sensory input, memory, attention, emotion, and prediction to produce a seamless sense of time. Seconds, minutes, hours, and even decades are filtered through layers of perception, creating a personal temporal reality. This integrated perception allows humans to navigate complex environments, build memories, plan for the future, and connect with the wider rhythms of life and nature as you drift into deeper relaxation. Allow yourself to feel the subtle workings of your brain shaping time around you. Sense how each breath, heartbeat, and thought contributes to your perception of the present moment. Feel the interplay of memory and anticipation, the stretching and compressing of subjective duration, and the seamless flow that binds past, present, and future into your consciousness. Time, as experienced by your mind, is at once flexible, structured, and profoundly personal, a continuous dance of perception, cognition, and awareness. By contemplating these mechanisms, we begin to understand that our experience of time is not merely a reflection of clocks or calendars. It is a living, dynamic construct shaped by neural networks, emotional states, attention, memory, and even culture. The human brain, in its complexity, allows us to experience time not only as a measurable dimension, but also as a rich, nuanced landscape of conscious experience.